Hello, Namaskara ಎಲ್ಲರಿಗೂ. Welcome you all to the Vedantu Karnataka. ನಾನು ನಿಮ್ಮ ಮಾಸ್ಟರ್ ಟೀಚರ್ Rithika Ma'am. So ಇವತ್ತಿನ ಟಾಪಿಕ್ ಏನಪ್ಪ, DF ಎಲಿಮೆಂಟ್. ಓಕೆ, ಸೊ ಇವತ್ತು ಫುಲ್ PU ಬೋರ್ಡ್ ಮತ್ತೆ KCET ಮೇಲೆ ಫುಲ್ ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡೋಣ. And even I want the answer from you people also, that I am audible and visible properly to everyone. Okay, it's just a little bit. I'll just change the settings. Just give me 1 second, guys. Just give me 1 sec. I'm audible properly now. All perfect? Let me check once. Yes. Hi, Vinay. Hi. Yes, now it's all clear. Yes, this video can crack KCET, guys. ನೀವು ಕನ್ಸಿಸ್ಟೆನ್ಸಿ ಮೇಂಟೈನ್ ಮಾಡಿ ಕುಂತು ಓದಿದ್ರೆ ಏನು ಕ್ರ್ಯಾಕ್ ಮಾಡ್ಕೋಬೋದು. ನಾ ಆಲ್ರೆಡಿ ಮೊದಲು ಹೇಳಿದ್ದೆ ನಿಮಗೆ, ಕನ್ಸಿಸ್ಟೆನ್ಸಿ ರಿಯಲಿ ಹೆಲ್ಪ್ಸ್ ಯು ಅ ಲಾಟ್. ಓಕೆ, ಸೊ ಭಾಳ ಮಂದಿ ಕೇಳ್ತಾರೆ, ಮ್ಯಾಮ್ ಇಷ್ಟೆಲ್ಲ ಕುಂತು ಓದಿದ್ರೆ ಸಾಕಾ ಅಂತ. ಸೊ ಇವೆಲ್ಲ ಕುಂತು ಓದಿದ್ರೆ ರಿಯಲಿ ಸಾಕು ನಿಮಗೆ. ಓಕೆ, ಸ್ವಲ್ಪ ಪ್ರಾಕ್ಟೀಸ್ ಇರಬೇಕು. ಯಾವ್ಯಾವ ಕ್ವಶನ್ಸು ಯಾವ ಚಾಪ್ಟರ್ಸಿಂದ ಹೇಗೆ ಕೇಳ್ತಾರೆ ಅನ್ನೋದು ಪ್ರಾಕ್ಟೀಸ್ ಇರಬೇಕು ನಿಮಗೆ. ಬರೇ ಕುಂತು ಥಿಯರಿ ಓದ್ತೇನೆಂದರೆ ಆಗಲ್ಲ. ಕ್ವಶನ್ ಪ್ರಾಕ್ಟೀಸ್, ಟೇಕಿಂಗ್ ಅ ಮಾಕ್ ಟೆಸ್ಟ್, ದಿಸ್ ಆಲ್ ಆರ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ಇವನ್ನೆಲ್ಲ ಮಾಡ್ಕೊಂತ ಹೋದರೆ ಆರಾಮಾಗಿ ನೀವು KCET ಕ್ರ್ಯಾಪ್ ಮಾಡ್ಕೋಬಹುದು. ಏನೂ ಪ್ರಾಬ್ಲಮ್ ಆಗಲ್ಲ. ಜಸ್ಟ್ ಏನು ಡೈಲಿ ವೈಸ್ ಟೈಮ್ ಟೇಬಲ್ ಇಟ್ಕೊಂಬಿಡಿ. ಮತ್ತು ಈ ಸಬ್ಜೆಕ್ಟ್ ಇವತ್ತು ಇಷ್ಟು ಓದಬೇಕಪ್ಪ, ಅದು 10 ಕ್ವಶನ್ ಸಾಲ್ವ್ ಮಾಡಬೇಕು. ಇವನ್ನೆಲ್ಲ ಮಾಡಿದರೆ ಇಟ್ ವಿಲ್ ರಿಯಲಿ ಹೆಲ್ಪ್ ಯು ಪೀಪಲ್. ಓಕೆ, yes, this video is really helpful. I should speak in Hindi na. Why you don't know Kannada? ಪ್ರಶಾಂತ್, ಕನ್ನಡ ಗೊತ್ತಿಲ್ವಾ ನಿಂಗೆ? ಕನ್ನಡ ಗೊತ್ತಿಲ್ವಾ ಪ್ರಶಾಂತು? हिंदी में बोलो. ओके, कौन सी लैंग्वेज है? ये कन्नड़ा लैंग्वेज है. ಓಕೆ, ಸೊ ಲೆಟ್ ಸ್ಟಾರ್ಟ್ ವಿತ್ ದ ಚಾಪ್ಟರ್. ಸೊ ಸೆಕೆಂಡ್ PUC ಮತ್ತು KCET ಮೇಲೆ ಫುಲ್ ಫೋಕಸ್ಡ್ ಚಾಪ್ಟರ್ ಇದು. ಹೇಗಪ್ಪ ಮಾಡ್ತೇನೆ, ನಾನು ಮೊದಲು DF ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ ಮೊದಲು ಮಾಡಿದ್ದೆ. ನಿಮಗೆ ಮೊದಲು ಒಂದು ಸಜೆಷನ್ ಕೊಟ್ಟಿದ್ದೆ. ಏನಪ್ಪ ಅದು ಸಜೆಷನ್ ಅಂದರೆ, ಇಟ್ಸ್ ಲೈಕ್ ಯು ಪೀಪಲ್ ನೀಡ್ ಟು ಬಿ ವೆರಿ ಮಚ್ ಕನ್ಸಿಸ್ಟೆನ್ಸಿ ಫಾರ್ ದಿಸ್ ಚಾಪ್ಟರ್. ಯಾಕಂದರೆ ಫುಲ್ ಆಫ್ ಕನ್ಸೆಪ್ಷನಲ್ ಇರುತ್ತೆ. ಲೈಕ್ ವಾಟ್, ಏನೋ ಒಂದು ಸರಿಯಾಗಿ ಹೋಗ್ತಿದೆ ಚಾಪ್ಟರು, ಮತ್ತು ಅದರಲ್ಲಿ ಒಂದು ಏನಾದರೂ ಒಂದು ಬಂದುಬಿಡುತ್ತೆ. ಸೊ ಇಟ್ಸ್ ಲೈಕ್ ಯು ನೀಡ್ ಟು ರಿಮೆಂಬರ್ ಅ ಲಾಟ್ ಆಫ್ ಥಿಂಗ್ಸ್ ಇನ್ ದಿಸ್ ಚಾಪ್ಟರ್. ಓಕೆ, ನಾನು ಸ್ಟಾರ್ಟಿಂಗೇನೆ ನೀವು ಡಿಮೋಟಿವೇಟ್ ಮಾಡ್ತೀನಿ ನಿಮಗೆ. ಜಸ್ಟ್ ದ ಥಿಂಗ್ ಇಸ್, ನೀವು ಮೊದಲೇ ರೆಡಿ ಇರಬೇಕು. ಈ ಚಾಪ್ಟರ್ ಯಾವಾಗ ಓದ್ತಿರ್ತಾರಲ್ಲ, ಮೊದಲೇ ರೆಡಿ ಇರಬೇಕು. ನೀವು ಭಾಳ ಟಾಪಿಕ್ಸ್ ಬರೋದಿದೆ, ಅದರಲ್ಲಿ ನಿಮಗೆ ಕನ್ಫ್ಯೂಷನ್ ಆಗಬಹುದು. ಬಟ್ ಯಾವ ಥರ ಅದನ್ನು ನೆನಪಿಟ್ಕೋಬೇಕು ಅನ್ನೋದು ನಿಮ್ಮ ಐಡಿಯಾ ಗೊತ್ತಿರಬೇಕು. ಓಕೆ, ಕ್ಲಿಯರ್? ಡನ್? Okay, then let's start with the introduction first. Before we start this, I wanted to show you people first the time periodic table first. So, this periodic table yakappa important ide. Okay, why this periodic table is very much important. So, each chapter completely it's based on the periodic table. Aita. So, this is inorganic chapter actually. Okay, so this completely it is based on the periodic table. ನೀವು ಯಾವ ತರ periodic table ಅನ್ನ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೋತಿರಲ್ಲ ಆ ತರ ನಿಮಗೆ ಈ ಚಾಪ್ಟರ್ ಅನ್ನು ಕ್ಲಿಯರ್ಲಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗುತ್ತೆ. ಈಗ ನಿಮಗೆ ಗೊತ್ತಿದೆ ಆಲ್ರೆಡಿ ದಿಸ್ ಆರ್ ಆಲ್ ದ ಎಲಿಮೆಂಟ್ಸ್ ವಿಚ್ ಆರ್ ಪ್ರೆಸೆಂಟ್, right? So these all are elements. In this you people are going to learn only D and F block elements. Okay, separate agi. Actually ಮೊದಲಿನ portion ನಲ್ಲಿ SP P block separate chapter ಇತ್ತು ನಿಮಗೆ, and even you are having it. Just let me check I am audible properly or no. Yes, it's all clear. ಸೊ ಅದ್ರ ಸಲುವಾಗಿ ನಿಮ್ಗೆ ಏನು ಪ್ರಾಬ್ಲಮ್ ಆಗ್ತಿತ್ತು ಅಂದರೆ ಭಾಳ ಮಂದಿಗೆ ಏನು ಪ್ರಾಬ್ಲಮ್ ಆಗ್ತಿತ್ತು ಅಂದರೆ ಇಲ್ಲಿ ಪಿ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ನಲ್ಲಿ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಎಲಿಮೆಂಟ್ಸ್ ಇರ್ತಿದ್ದು ಕಂಪೇರ್ ಟು ದ ಡಿ ಆ್ಯಂಡ್ ಎಫ್ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್. ನಾವು ದೇ ಹ್ಯಾವ್ ರಿಮೂವ್ಡ್ ದ ಚಾಪ್ಟರ್ ಫ್ರಮ್ ದ NCERT, ಸೊ ಆರಾಮ್ ಸೇ ಯು ಪೀಪಲ್ ಕ್ಯಾನ್ ಕೂಲಿ ಸ್ಟಡಿ ಓನ್ಲಿ ದ ಡಿ ಆ್ಯಂಡ್ ಎಫ್ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್. ಓಕೆ, ಸೊ ಇನ್ ದಿಸ್ ಡಿ ಆ್ಯಂಡ್ ಎಫ್ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಲರ್ನ್ ಅಬೌಟ್ ದ lanthanides, actinides also, and some elements of D. ಓಕೆ, ಸೊ ಡಿದಿಂದ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸನ್ನು ಚೆನ್ನಾಗಿ ಕಲ್ಕೊಳ್ಳೋಣ, ಯಾವುದು ಮತ್ತು ಎಲ್ಲಿಂದ ತೊಗೊತಿದ್ದಾರೆ ಅನ್ನೋದು ಐಡಿಯಾ ಇರಬೇಕಲ್ಲ ನಿಮಗೆ. ಸೊ ಐ ಜಸ್ಟ್ ಶೋನ್ ಯು ದ ಪೀರಿಯಾಡಿಕ್ ಟೇಬಲ್ ಸೊ ದಟ್ ಯು ವಿಲ್ ಹ್ಯಾವ್ ಅ ಐಡಿಯಾ ದಟ್ ಹೌ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಲರ್ನ್ ದೋಸ್ ಥಿಂಗ್ಸ್. ಓಕೆ, ಬಿಫೋರ್ ದ್ಯಾಟ್ ಐ ವಾಂಟ್ ಟು ಟೆಲ್ ಯು ಪೀಪಲ್ ಎಷ್ಟಪ್ಪ ಮಾರ್ಕ್ಸ್ ಬೀಳ್ಬಹುದು. ಓಕೆ, ಎಷ್ಟಪ್ಪ ಮಾರ್ಕ್ಸ್ ಬೀಳ್ಬೋದು ಇದರಿಂದ. So you people might receive almost, okay, almost 2 to 3 marks for KCET. Okay, KCET ಗೆ almost 2 to 3 marks ಬೀಳಬಹುದು, and even for the main exams up till 4 marks you can receive it. Okay, PU exam ಗೆ almost 5 marks receive ಮಾಡ್ಕೋಬಹುದು. So today's class I have even taken the questions which are being come in the board exams also. Okay, board exams ನಲ್ಲಿ ನೀವು ಯಾವ ತರ questions ಕೇಳಿದ್ದಾರೆ ಈ ಚಾಪ್ಟರ್ ಇಂದ ಅವನು questions ತಗೊಂಡಿದ್ದೇನೆ, plus I have taken the KCET questions also. Both the things we'll see it till the end of the class. First we'll try to understand what is actually topic is saying us. Okay, ಏನ್ ಟಾಪಿಕ್ ಹೇಳ್ತಿದೆ ಅನ್ನೋದು ನೋಡ್ಕೊಳ್ಳೋಣ. ಮೇಡಮ್ KCET ಲೆಕ್ಚರ್ ಇದು ಎಸ್ KCET ಪ್ಲಸ್ PU ಬೋರ್ಡ್ ಲೆಕ್ಚರ್ ಅಪ್ಪ, ಎರಡೂ ಬಗ್ಗೆ ಹೇಳ್ತೇನೆ. ಇಟ್ಸ್ ರಿಲೇಟೆಡ್ ಟು ಬೋತ್ ದ ಥಿಂಗ್ಸ್. ಓಕೆ, KCET ಬಗ್ಗೆನೂ ಹೇಳ್ತೇನೆ ನಿಮಗೆ, ಕ್ವಶನ್ಸ್ ಯಾವ ಥರ ಯಾವ ಟಾಪಿಕ್ಕು KCET ಭಾಳ ಫೋಕಸ್ಡ್ ಇದೆ ಆ್ಯಂಡ್ ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ಸ್ ಯಾವ ಥರ ಫೋಕಸ್ಡ್ ಇದೆ ಅನ್ನೋದು ಫುಲ್ ಎರಡೂ ಹೇಳ್ಕೊಡ್ತೇನೆ ನಿಮಗೆ. ಜಸ್ಟ್ ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಿ ಬುಕ್ ಪೆನ್ ತೊಗೊಳ್ಳಿ, ಮುಂದೆ ಕುಂತ್ಕೊಂಡು ಟಾಪಿಕನ್ನು ಬರ್ಕೊಳ್ಳಿ. ನಾ ಏನು ಹೇಳಿದ್ದೇನೆ ಅದೆಲ್ಲ ಫುಲ್ ಬರ್ಕೊಳ್ಳೋದು ನೆಸೆಸಿಟಿ ಇಲ್ಲ, ಬಟ್ ಯು ಪೀಪಲ್ ಕ್ಯಾನ್ ಜಸ್ಟ್ ನಾ ಯಾವಾಗ ಇಂಪಾರ್ಟೆಂಟ್ ಅಂತ ಮೆನ್ಷನ್ ಮಾಡ್ತೇನಲ್ಲ ಅವಾಗೆಲ್ಲ ನೀವು ಬರ್ಕೋಬಹುದು ಅದನ್ನ. ಓಕೆ, ಲೆಟ್ಸ್ ಸ್ಟಾರ್ಟ್ ದೆನ್. ಸೊ ಫಸ್ಟ್ ಇಸ್ ಅಬೌಟ್ ದ ಇಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್. ನೀವು ಫಸ್ಟ್ ಇದ್ರದ್ದು ಇಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೋಬೇಕು. ಓಕೆ, ಇಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಅಂದ್ರೆ ಏನಪ್ಪ ನಿಮಗೆ ಗೊತ್ತಿದೆ ಆಲ್ರೆಡಿ, ರೈಟ್? Madam, new batch it's not new batch. We have already started this batch a long back. So next week we are going to start with the FA3 classes also. Please tell in the comment section ಯಾರ್ಯಾರ್ದು FA3 exams ಬರ್ತಿದೆ, ಯಾವಾಗ ಡೇಟ್ಸ್ ಇದೆ, ಏನಪ್ಪ ಪೋರ್ಷನ್ ಇದೆ ಅನ್ನೋದು, ಯಾರ್ಯಾರು ಆಫ್ಲೈನ್ ಆಮೇಲೆ ಲೈವ್ ಬಿಟ್ಟು ಬೇರೆ ಕಡೆ ನೋಡ್ತಿದಾರಲ್ಲ ಕಮೆಂಟ್ ಸೆಕ್ಷನ್ ಅಲ್ಲಿ ಹೇಳಿ. ಈಗ ರೈಟ್ ನಾವ್ ಯು ಪೀಪಲ್ ಕ್ಯಾನ್ ಮೆಸೇಜ್ ಮೀ ಇನ್ ದ ಲೈವ್ ಇಟ್ ಸೆಲ್ಫ್ ದಟ್ ಯಾವ ಟಾಪಿಕ್ಸ್ ನಿಮ್ಗೆ ಎಕ್ಸಾಮ್ ನಲ್ಲಿ ಇದೆ ಮತ್ತೆ ಯಾವಾಗ ನಿಮ್ದು ಎಕ್ಸಾಮ್ಸ್ ಇದೆ ಅನ್ನೋದು ನಮಗೆ ಐಡಿಯಾ ಗೊತ್ತಾಗಬೇಕಲ್ಲ. Because different colleges will have a different exam patterns, so portion different irutte adha salagi namagu ಸ್ವಲ್ಪ ಐಡಿಯಾ ಗೊತ್ತಾಗುತ್ತೆ if you people will help us out. Okay, ಫಾಸ್ಟ್ ಆಗಿ ಎಲ್ಲರೂ ಹೇಳಿ ನೋಡೋಣ ಎಷ್ಟು ಮಂದಿ ಹೇಳ್ತಾರೆ ಯಾವಾಗ ಎಕ್ಸಾಮ್ಸ್ ಬರ್ತಿದೆ ನಿಮ್ಮದು ಅನ್ನೋದು. ಆಯ್ತಾ? when your exams are coming. ಮೇಡಮ್ ನಾನು ಲಾಂಗ್ ಟರ್ಮ್ KCETಗೆ ಟಾರ್ಗೆಟ್ ಮಾಡ್ತಿದ್ದೀನಿ. ಎಸ್ ಯು ಕ್ಯಾನ್ ಡೂ ಇಟ್. ಇದನ್ನ ಚಾಪ್ಟರ್ನ ಚೆನ್ನಾಗಿ ಓದು, ಆರಾಮಾಗಿ 2 ರಿಂದ 3 ಮಾರ್ಕ್ಸ್ ಬೀಳುತ್ತೆ KCET ಎಕ್ಸಾಮ್ಸ್ಗೆ. ಸೊ ಯು ಕ್ಯಾನ್ ಕಾನ್ಸಂಟ್ರೇಟ್ ಆನ್ ದಿಸ್ ಆಲ್ಸೋ. ಯು ವಿಲ್ ಆರಾಮ್ಸೆ ರಿಸೀವ್ ದ ಮಾರ್ಕ್ಸ್ ಇಫ್ ಯು ಹವ್ ಅಂಡರ್ಸ್ಟುಡ್ ದ ಟಾಪಿಕ್ ಪ್ರಾಪರ್ಲಿ. ಓಕೆ, ಸೊ ಲೆಟ್ಸ್ ಸ್ಟಾರ್ಟ್ ದೆನ್. ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಆಫ್ ZN, CD, HG and CN are actually been involved in the transition series but are not considered as a transition series. Okay, so idenidella zinc, canadium, Hg and Cn, this all elements which are present, this are actually involved in the transition series. Okay, transition series nalli involve agide idu. Okay, but they are not considered as a transition elements. Yakappa, this can be asked for the give reasons. Okay, yakandre because they have completely filled d orbitals. So ivella transition elements. ಓಕೆ ಡಿ ಇವೆಲ್ಲ ಝೆಡ್ ಎನ್ ಸಿ ಡಿ ಎಚ್ ಜಿ ಸಿ ಎನ್ ಅವೆಲ್ಲ ಟ್ರಾನ್ಸಿಷನ್ ಸೀರೀಸ್ನಲ್ಲಿದೆ ಬಟ್ ದೇ ವಿಲ್ ನಾಟ್ ಕನ್ಸಿಡರ್ ವೈ ಬಿಕಾಸ್ ದೀಸ್ ಆರ್ ಆಲ್ ಫಿಲ್ಡ್ ಡಿ ಆರ್ಬಿಟಲ್ ಇಸ್ ಫಿಲ್ಡ್ ಒನ್ ಸೆಕೆಂಡ್ ಡಿ ಆರ್ಬಿಟಲ್ ಇಸ್ ಕಂಪ್ಲೀಟ್ಲಿ ಫಿಲ್ಡ್ ಸೊ ಇದನ್ನ ಗಿವ್ ರೀಸನ್ ಆಗಿ ಕೇಳಬಹುದು they might ask these things for the give reason also because each chapter in the PU board nalli completely focused on the PU board daga they will completely focus more on the give reasons itself. So give reasons questions like and first of all madle helbiಡ್ತೇನೆ ನಿಮಗೆ D and F block element in the D and F block element in the completely D and F block element ಇದೆಯಲ್ಲ ಆ ಚಾಪ್ಟರ್ ಇಂದ ಮೋಸ್ಟ್ ಪ್ರಾಬಬಲಿ ಡೈರೆಕ್ಟ್ಲಿ ಕಂಪ್ಲೀಟ್ಲಿ 5 ಮಾರ್ಕ್ಸ್ ಅಂತ ಯಾವುದು ಕೇಳಲ್ಲ ಕ್ವಶನ್ ಸ್ಟ್ರೇಟ್ ಫಾರ್ವರ್ಡ್ ಆಗಿ ಹೇಳ್ತಿದ್ದೇನೆ 5 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್ ಕೇಳಲ್ಲ 5 ಮಾರ್ಕ್ಸ್ ನಲ್ಲಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗುತ್ತೆ ಮಾರ್ಕ್ಸ್ ಹೇಗಪ್ಪ A B C ಆ ತರ ಇಟ್ ವಿಲ್ ಬಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟೆಡ್ ಓಕೆ A B C ಇಲ್ಲಾಂದ್ರೆ A B ಈ ತರ ಕ್ವಶನ್ಸ್ ಅನ್ನ ಕೇಳ್ತಾರೆ ಸೊ ಜಸ್ಟ್ ಬಿ ಫೋಕಸ್ಡ್ ಆನ್ ದೋಸ್ ಥಿಂಗ್ಸ್ ಯಾಕೆ ಅಂದ್ರೆ ನಾನು ಗಿವ್ ರೀಸನ್ ಹೇಳಿದೆ ಇದನ್ನ ಎಷ್ಟು ಮಾರ್ಕ್ಸ್ ಕೇಳಬಹುದಪ್ಪ 1 ಮಾರ್ಕ್ಸ್ ಇಲ್ಲಾಂದ್ರೆ 2 ಮಾರ್ಕ್ಸ್ ಕೇಳ್ತಾರೆ ರೈಟ್ ಸೊ ದಿಸ್ 2 marks question they might add up in the 5 marks also. So you need to be focused on each and every topic properly. Ma'am ಇದು ದೊಡ್ಡದಿದೆ ಮ್ಯಾಮ್ ಇದು 5 ಮಾರ್ಕ್ಸ್ ಕೇಳ್ತಾರಾ ಅಂತ ಇಲ್ಲ ದೊಡ್ಡದಿದ್ರೂ 5 ಮಾರ್ಕ್ಸ್ ಕೇಳಲ್ಲ they usually ask D and F block elements in the part wise itself. Okay, so be focused on this also. So what is this? Zn, Cd, Hg and Cn, these are all involved in the transition series. Why? Because they are included in the transition series but they are not considered as a transition elements. ಯಾಕಂದ್ರೆ ಡಿ ಆರ್ಬಿಟಲ್ ಫೀಲ್ಡ್ ಕಂಪ್ಲೀಟ್ಲಿ ಡಿ ಆರ್ಬಿಟಲ್ ಏನಿದೆಯಲ್ಲ ಫಿಲ್ ಆಗಿರುತ್ತೆ ಅದರ ಸಲುವಾಗಿ ಅದನ್ನ ಇನ್ಕ್ಲೂಡ್ ಮಾಡ್ಕೊಳ್ಳಲ್ಲ ಕ್ಲಿಯರಾ ಸೊ ಎಫ್ ಎ ಎಕ್ಸಾಮ್ಸ್ ಯಾವಾಗಿದೆ ಯಾರ್ಯಾರು ಗೊತ್ತಾಗಿದೆ ಅದನ್ನೆಲ್ಲ ಹೇಳಿ ಫಾಸ್ಟ್ ಆಗಿ ಲೆಟ್ಸ್ ಸಿ ಎಸ್ ಯಾರು ಕ್ಲಾಸ್ ನೋಡ್ತಿದಾರಲ್ಲ ಫಾಸ್ಟ್ ಆಗಿ ಹೇಳಿ ನಮಗೆ ಎಫ್ ಎ ಎಕ್ಸಾಮ್ಸ್ ಯಾವಾಗ ಬರ್ತಿದೆ ನಿಮ್ಮದು ಡೇಟ್ಸ್ ಮೆನ್ಷನ್ ಮಾಡಿ ನಮಗೆ ಆ್ಯಂಡ್ ಈವನ್ ಟೆಲ್ ದ ಪೋರ್ಷನ್ ಫಾರ್ ದಿಸ್ ಓಕೆ Now, first question related to that itself. On what ground can you say that the scandium, that is Z is equal to 21 as its atomic number, is a transition element, but the zinc Z is going to be the 30? Why it is not? Okay, they have asked the question. I told you people give reasons ಜಾಸ್ತಿ ಕೇಳ್ತಾರಂತ ಸೊ ಈ ತರ ಕ್ವಶನ್ಸ್ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ ಆಯ್ತಾ ಸೊ ಸ್ಕ್ಯಾಂಡಿಯಮ್ is actually having a Z is equal to 21. Ground state of the configuration is going to be how much? AR. This is going to be the argon. Directly argon do electronic configuration ತಗೊಂಡಿದ್ದಾರೆ you have already idea about it in the your first year classes ಹೇಗಪ್ಪ ಇವನು ತಗೊಳ್ಳಬೇಕು ಅನ್ನೋದು ಆಯ್ತಾ so this is electronic configuration that the ground state for the scandium okay that is SC it is also called as SC now has come completely filled in 3D orbitals so completely in D orbital ನಲ್ಲಿ incomplete ಇದೆ it's actually incomplete okay this is actually having a incomplete series means d block d orbital completely fill agilla okay now ಈಗ ಏನಾಗುತ್ತೆ so it is not completely filled hence classified as a transition element now because of that we are going to include that in the transition element clear one more question they have asked that is about the zinc ನಲ್ಲಿ ಏನಾಗುತ್ತೆ they have given the atomic number as a 30 right again you are going to take it again you are going to write the electronic configuration of those things ground state configuration AR is going to be what 3D is going to be a 10 and S is going to have a charge as 2. Now this is completely filled, right? It is completely filled, has completely filled d orbitals in both the ground and the oxidized states, hence not considered as a transition elements. So with this both examples, with this question, we are going to come to one conclusion. ಏನಪ್ಪ ಅದು conclusion ಏನಂದ್ರೆ ಯಾವ್ಯಾವ d orbital ಏನ್ d orbital ಇದೆ ಅಲ್ಲ this d orbital which is there ಇದ್ರಾಗ In case ಯಾವ್ದಾದ್ರು d orbital ನಲ್ಲಿ electrons completely fill ಆಗಿಲ್ಲಪ್ಪ, ಓಕೆ, electrons completely fill ಆಗಿಲ್ಲ, ಅವನ್ನೆಲ್ಲ transition elements ಅಂತ ಕರೀತಾರೆ. They are all classified into transition elements. If it is filled, then it is going to be not be considered in the transition elements. Exceptionals are this. Exceptionals ಅಂತ ಇದಿರುತ್ತೆ. This will be the exceptional, but this also you need to remember it. Okay, idnu ನೆನಪಿಟ್ಕೋಬೇಕು ಆಯ್ತಾ. Done. Next comes what? Next question, one more. Silver atom has completely filled d orbital in its ground state. Okay, silver is actually completely filled d orbital. Elli ground state nalli completely fill agide silver already. Okay, how can you say that it is a transition element? See, ನಾ ಈಗ ಹೇಳಿದೆ ಏನಂತ ಟ್ರಾನ್ಸಿಷನ್ ಎಲಿಮೆಂಟ್ ಅಂದರೆ ಏನು. ಇನ್ ಕೇಸ್ ಡಿ ಆರ್ಬಿಟಲ್ನಲ್ಲಿ ಕಂಪ್ಲೀಟ್ಲಿ ಫಿಲ್ ಆಗಿಲ್ಲಪ್ಪ, ಯಾವ್ಯಾವ ಇಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ ಅಲ್ಲ ಕಂಪ್ಲೀಟ್ಲಿ ಫಿಲ್ ಆಗಿಲ್ಲ, ಅವನ್ನೆಲ್ಲ ಟ್ರಾನ್ಸಿಷನ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ಹೇಳಿದೆ. ಸೊ ಯಾವ್ಯಾವ ಫಿಲ್ ಆಗಿದ್ದಾವೆ ಅವು ಟ್ರಾನ್ಸಿಷನ್ ಎಲಿಮೆಂಟ್ಸ್ನಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡಲ್ಲ. ಬಟ್ ದೇ ಹ್ಯಾವ್ ಟೋಲ್ಡ್ ದ್ಯಾಟ್ ಸಿಲ್ವರ್ ಇಸ್ ಆಕ್ಚುಲಿ ಫಿಲ್ಡ್, ಡಿ ಆರ್ಬಿಟಲ್ ಫಿಲ್ ಇದೆ, ಅದು ಟ್ರಾನ್ಸಿಷನ್ ಎಲಿಮೆಂಟ್ ಇಲ್ಲ, ಬಟ್ ಆಲ್ಸೋ telling that it is a transition element. Okay, ಅಂದ್ರೂನು transition element ಅಂತ ಕರೀತಿದ್ದಾರೆ. ಯಾಕಪ್ಪ ಅನ್ನೋದು ರೀಸನ್ ಹೇಳಿದ್ದಾರೆ. Okay, so what is that? Silver, that is Ag, has a ground state configuration of Kr krypton 4d10 and 5s1. You can just observe here it is 4d10. It's completely filled d orbital. Okay, and d orbital is completely filled, so it does not qualify as a transition element in the ground state. Okay, adantu qualify agalla because as we have learned it previous question in the ink kaltidevalla adar prakara antu agalla aita. So now what happens, however, in its +2 oxidation state, that is Ag becomes 4d9. ಯಾವಾಗ ಆಗುತ್ತೆ ಅದು? when it is getting oxidized. Okay, ಯಾವಾಗ ನಾವು oxidation ಆಗ್ತಿದೆ ಅಲ್ಲ, come on, be active in the chat box. Understanding everyone? Clear this one? Clear? Clear everyone this one? Understand ಆಗ್ತಿದೆನಾ? Be active in the chat box everyone. Next comes what? In its +2 oxidation state. So ಯಾವಾಗದು Ag ಇರುತ್ತಲ್ಲ, this is when it is going to be +2 oxidation state ನಲ್ಲಿ ಇರುತ್ತೆ. Okay, ಯಾವಾಗಿದು +1 oxidation state means oxidize ಆಗ್ತಿದೆ. +2 ಯಾವಾಗ ಬರುತ್ತೆ? when it is losing the electrons, right? So whenever we have a plus sign, we are going to lose the electron, right? So ಯಾವಾಗದು lose ಆಗ್ತಿದೆ, electrons ಕೊಡ್ತಿದೆ ಅಪ್ಪ ಯಾರಿಗೋ. Okay, that time what is going to happen? That time it is going to become what? 4d9. So ಈಗ 4d9 ಆಗಿದೆ. It's not filled, ಬರೀ one electron ಬೇಕಿದೆ ಅಪ್ಪ ಇದಕ್ಕೆ. So now this means it has an incomplete d orbital in at least a one common ion. It means what? Whenever it is getting oxidized, silver ಯಾವಾಗ oxidize ಆಗುತ್ತೆ at +2 oxidation state ನಲ್ಲಿ, ಅವಾಗೆಲ್ಲ it is considered as transition elements. Clear? So hence Ag is classified as a transition element. That's what I was trying to tell you people. So ಈ ತರ ಕ್ವಶನ್ಸ್ ಬಹಳ ರಿಪೀಟ್ ಆಗಿದೆ, ಇವೆಲ್ಲ ರಿಪೀಟೆಡ್ ಕ್ವಶನ್ಸ್ ಆಯ್ತಾ. ಟ್ರಾನ್ಸಿಷನ್ ಎಲಿಮೆಂಟ್ ಬೈ IUPAC ಡೆಫಿನೇಷನ್. ಅಕಾರ್ಡಿಂಗ್ ಟು ದಿಸ್ ರೀಸನ್ ಸಿಲ್ವರ್, ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕನ್ಸಿಡರ್ ದ ಸಿಲ್ವರ್ in the form like we are going to when it is getting oxidized, we are going to consider them as a transition element. Done? So let me know when you are next comes the physical properties. Now physical properties ಏನಾಗುತ್ತಪ್ಪ? Now you are clear everyone with the transition elements? Done? Yes, Nagaraj, clear? So ಬರೀ ನಾಗರಾಜ್ಗೆ ಅಷ್ಟೇ ತಿಳಿತಾ, ಉಳಿದವ್ರಿಗೆ ತಿಳಿದಿಲ್ವಾ? Fast ಆಗಿ ಹೇಳಿ. Who understood this? Transition elements are clear to everyone? Done? Yes, then let's start with the physical properties. So here we are going to learn in a detail about the physical properties first, okay? Then afterwards we are going to go for some questions also, okay? We will go for the questions also. Hi Anjali, hi. Yes, very good. Okay. Typical metallic properties such as high tensile strength. What is the meaning of an high tensile strength? ಮ್ಯಾಮ್ ಏನದು ಟೆನ್ಸೈಲ್ ಸ್ಟ್ರೆಂತು, ಹೇಗಪ್ಪ ಮ್ಯಾಮ್ ಅದು? ನಾವು ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೇನೆ ನಿಮ್ಗೆ ಡೈಲಿ ಲೈಫ್ದು. ಸೊ ಒಂದು ಸ್ಪ್ರಿಂಗ್ ತೊಗೊಳ್ಳಿ, ಓಕೆ, ಸ್ಪ್ರಿಂಗ್ ತೊಗೊಂಡ್ಬಿಡಿ. ಇಲ್ಲಾಂದರೆ ಒಂದು ಸಿಂಪಲ್ ಎಕ್ಸಾಂಪಲ್, ನೀವು ಟಂಗ್ ಕ್ಲೀನಿಂಗ್ ಸ್ಪ್ರಿಂಗ್ ನೋಡಿರಬೇಕು, ಯೂಶ್ವಲಿ ನೋಡಿರ್ಬೋದು ಎಲ್ಲರೂ, ಬಟ್ ಇನ್ ಕೇಸ್ ಯಾರೂ ನೋಡಿಲ್ಲ ಅಂದರೆ ಜಸ್ಟ್ ಒಂದು ನಾರ್ಮಲ್ ಸ್ಪ್ರಿಂಗ್ ತೊಗೊಂಡ್ಬಿಡಿ, ಓಕೆ ಸ್ಪ್ರಿಂಗ್ ತೊಗೊಂಬೇಡಿ, ಆ ಸ್ಪ್ರಿಂಗ್ ಅನ್ನ ತಗೋ, ಹಲೋ ಅಂಜಲಿ. ಸೊ ಸ್ಪ್ರಿಂಗ್ ಅನ್ನು ತಗೊಂಡು ಫುಲ್ ಸ್ಪ್ರೆಡ್ ಮಾಡಿ. ಓಕೆ ಜಸ್ಟ್ ಸ್ಪ್ರೆಡ್ ಇಟ್ ಪ್ರಾಪರ್ಲಿ ಟು ಎವ್ರಿ ಒನ್. ದೆನ್ ಆಗ್ತಿರ್ತದಲ್ಲ ಸ್ಪ್ರಿಂಗು, ಅವಾಗ ನಮಗೆ ಗೊತ್ತಾಗ್ತದೆ ಮೇಲ್ಕೆಳಗೆ ಹೋಗ್ತಿದೆ ಅನ್ನೋದು. ದಟ್ ವಿಸಿಬಿಲಿಟಿ ವಿಲ್ ಬಿ ದೇರ್, ರೈಟ್? ಸೊ ದಟ್ ವಿಸಿಬಿಲಿಟಿ ವಿಲ್ ಬಿ ದೇರ್, ರೈಟ್? ಸೇಮ್ ವೇ ದ ಟೆಕ್ಸ್ಟೈಲ್ ಸ್ಟ್ರೆಂತ್ ಕ್ಯಾನ್ ಬಿ ಫೌಂಡ್ ಔಟ್ with this. Okay, so all these physical properties like D block elements which are there, they all are having a high tensile strength. It has a good power in between the elements. Okay, now ductility is also high. Okay, malleability is there. Malleability also means what? It is having a very strong component. Okay, it will go and react with properly, it will malleable with everyone. Okay, properly. Then afterwards, high thermal and electrical conductivity. High thermal and electrical conductivity. High thermal means what? ಹೈ ಥರ್ಮಲ್ ಅಂದರೆ ಈಗ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ಬೋದು ನಾನು. ಥರ್ಮಸ್ ಗೊತ್ತಿರಬೇಕಲ್ಲ, ಟೀ ಕಾಫಿ ಎಲ್ಲರೂ ಟ್ರಾವೆಲ್ ಮಾಡ್ತಿದ್ರೆ ತೊಗೊಂಡು ಹೋಗ್ತಾರಲ್ಲ, ಅವಾಗ ಏನಾಗುತ್ತೆ ಅಂದರೆ ಇವು ಯಾರು ಎಲಿಮೆಂಟ್ಸ್ ಅದಾವಲ್ಲ, ಇಟ್ ವಿಲ್ ಹೆಲ್ಪ್ ದೇರ್. ಓಕೆ, ಟು ಸ್ಟೇ ಇಟ್ ಫಾರ್ ಅ ಲಾಂಗರ್ ಟೈಮ್, ಕೀಪ್ ಇಟ್ ಲಾಂಗರ್ ಟೈಮ್ ಟು ಕೀಪ್ ಇಟ್ ಹಾಟ್. ಅರೆ ಕೋಲ್ಡ್ ಇದ್ರೆ ಏನಾದರೂ ಕೋಲ್ಡ್ ಜಾಸ್ತಿ ಟೈಮ್ದಲ್ಲಿ ಇಡುತ್ತೆ. ಇಟ್ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ಅ ಟೈಮ್ ಲಿಮಿಟ್. 6 ತಾಸು ಆದ ತಕ್ಷಣ ಬಿಸಿ ಇರೋದು ತಣ್ಣಗಾಗುತ್ತೆ, ತಣ್ಣಗಿರೋದು ಬಿಸಿ ಆಗುತ್ತಪ್ಪ. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಕಂಟಿನ್ಯೂಡ್ ಓನ್ಲಿ, ದ್ಯಾಟ್ ಇಸ್ ನಾಟ್ ಗೋನ್ ಅ ಚೇಂಜ್. ಓಕೆ, hi Shali, what is this? Shailaja. Okay, hi Shailaja, hi Mahadev. Hi Shailaja, hi Mahadev, hi everyone. Late to the class. Okay, now transition elements mugisbitte. So next comes what? Metallic luster. So luster means what? Shiny things will be present on it. Shine ಆಗ್ತಾರಲ್ಲ, ನಾನು ಈಗ ಶೈನ್ ಆಗ್ತಿದ್ದೇನಲ್ಲ, ಹಾಗೆ ಶೈನ್ ಆಗೋದು. ಓಕೆ, ಸೊ ನೀವು ಯಾವ್ದಾದ್ರು ಒಂದು ಫುಲ್ ಮೇಕಪ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಹುಡುಗಿಯರು ಇಲ್ಲಾರ ಹುಡುಗರು ಫುಲ್ ಪೌಡರ್ ಹಚ್ಕೊಂಡು ಅಲ್ಲೆಲ್ಲ ನಿಂತರೆ ಲೈಟಲ್ಲಿ ಫುಲ್ ಹೊಳಿತಾರಲ್ಲ. ಸಿಂಪಲ್ ಎಕ್ಸಾಂಪಲ್ ಹೇಳಿದ್ರೆ ಬೆಂಗಳೂರಿನಲ್ಲಿ ಯಾವುದೂ ಮಾಲ್ಸ್ ಹೋಗಿ ಎಲ್ಲ ಕಡೆ ಹೊಳಿತೀರ ನೀವು. That is called as lustrous. Okay, these all elements are going to give you a shininess in your thing. Okay, why you will not watch it? Ma'am, I'm reading coordination compounds from you, ma'am. Okay, you are learning, it's okay. D and F is also very important. So fast ಆಗಿ ನಿಮ್ಮ FA3 ಎಕ್ಸಾಮ್ಸ್ ಮುಗ್ದಿದೇನೋ ಇಲ್ಲೋ ಮತ್ತೆ ಏನು ಪೋರ್ಷನ್ ಇದೆನೋ ಹೇಳಿ ಚಾಟ್ ಬಾಕ್ಸ್ನಲ್ಲಿ ಫಾಸ್ಟ್ ಆಗಿ. ಓಕೆ, ವಿತ್ ದ ಎಕ್ಸೆಪ್ಟೇಷನ್ಸ್ ಆಫ್ ZN, CD, HG and Mn, they have one or more typical metallic structures at normal temperature. Okay, at normal temperatures. That normal temperature, what is going to happen? So ZN, CD ಮತ್ತೆ HG ಮತ್ತೆ Mn ಇದೆಲ್ಲ, they all will be having a typical metallic structures ಅನ್ನ ಫಾಲೋ ಮಾಡುತ್ತೆ. ಕ್ಲಿಯರ್? ಡನ್? ಅಂಡರ್ಸ್ಟುಡ್? ಎಸ್. ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ದ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್. ಓಕೆ, ಈಗ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಯಾಕಪ್ಪ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ ಮತ್ತು ಅದರಲ್ಲಿ ಯಾವ ಥರ ಎಲಿಮೆಂಟ್ಸ್ ಇದೆ, ಯಾವ ಥರದ್ದು ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಹೈ ಇರುತ್ತೆ ಮತ್ತು ಯಾವ್ದ್ರದ್ದು ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಲೋ ಇರುತ್ತೆ. ಫಸ್ಟ್ ಒಂದು ಸಿಂಪಲ್ ಹೇಳ್ತೇನೆ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಅಂದರೆ ಏನು ಅನ್ನೋದು. ಓಕೆ, ಈಗ ಎಲ್ಲ ಥರದ್ದು ಎಲಿಮೆಂಟ್ಸ್, ವಿ ಹ್ಯಾವ್ ಆಲ್ಮೋಸ್ಟ್ 118 ಎಲಿಮೆಂಟ್ಸ್, ರೈಟ್? ಇಲ್ಲಿ 118 ಎಲಿಮೆಂಟ್ಸ್ನಲ್ಲಿ ಆಲ್ಮೋಸ್ಟ್ in those elements all will be having a melting point. Okay, ಎಲ್ಲ ತರದ್ದು ಒಂದು melting point ಇರುತ್ತೆ. One certain temperature they will be having it. At that certain temperature, if it goes down to that temperature, the compound, if it is in a different state, that is going to completely melt. If it is in a solid state, it will completely melt into the liquid state. Okay, then afterwards it slowly, if you increasing the temperature like that only, it will convert into the gaseous state also. Okay, this is how the temperature changes will be happening. Means what? Melting points, one compounds or one elements. Now let's check it like carbon only. Okay, carbon one melting point irutte. Okay, once that will cross that melting point, it will not be, means in the form of which state we want, at that stage it won't be the state. Okay, now the transition metals except Zn, Cd and Hg are very hard and have a low volatility. Okay, very hard ಅಂದ್ರೆ ಏನು, ಇವೆಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ಏನಿದೆ ಅಲ್ಲ, they are very strong. Okay, they are very strong, they are very hard, their textile strength is very good. Okay, so ಈಗ very hard and have low volatility means what? ಸಿಟ್ ಇರುತ್ತಲ್ಲ ನಮ್ಮಲ್ಲಿ ಹೇಗೆ ಸಿಟ್ ಬರುತ್ತಲ್ಲ, ಅದೇ ಥರ ಎಲಿಮೆಂಟ್ಸ್ನಲ್ಲಿನೂ ಸಿಟ್ ಇರುತ್ತಪ್ಪ. ಎಲಿಮೆಂಟ್ಸ್ ಆಲ್ಸೋ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ಅ ಆಂಗ್ರಿನೆಸ್. ಓಕೆ, ಏನಪ್ಪ ನಂಗೆ ಯಾವಾದರೂ ಏನಾದರೂ ಕೊಡಲಿಲ್ಲ ಸಿಟ್ ಮಾಡ್ಕೋತಾರಲ್ಲ, ಅದೇ ಥರ ಇಟ್ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ಅ ವೆರಿ ಲೋ ವೋಲ್ಟಾಲಿಟಿ. ಮೀನ್ಸ್ ಇಫ್ ಐ ವಿಲ್ ನಾಟ್ ಗಿವ್ ಟು ದಟ್ ಪರ್ಸನ್ ದಟ್ ಥಿಂಗ್ ಆಲ್ಸೋ, ನೋ ಪ್ರಾಬ್ಲಮ್, ದೇ ವಿಲ್ ನಾಟ್ ಟೆಲ್ ಅಸ್ ಎನಿಥಿಂಗ್. Okay, so that we can consider it. Okay, now high melting and boiling point due to the strong metallic bonds from unpaired electrons, from the unpaired electrons. Clear? So high melting and boiling point will be there due to the strong metallic bonds from unpaired electrons. Unpaired electrons andre ಏನು D block elements. So in case it has not been filled, orbitals are not been filled, then that time what we are going to consider is be active in the chat box everyone fast. So understanding everyone, ಎಲ್ಲರಿಗೂ ತಿಳಿತಲ್ಲ melting point ಏನಂತ. ಸೊ ಇಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಿ, ಇದು ಭಾಳ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್ ಇದೆ, ಭಾಳ ಸಲ ಈ ಕೇಳಿರೋ ಕ್ವಶನ್ ಇದು. ಓಕೆ, ಸೊ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದರೆ ಹೈ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಅಂಡ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಡ್ಯೂ ಟು ದ ಸ್ಟ್ರಾಂಗ್ ಮೆಟಲಿಕ್ ಬಾಂಡ್ಸ್ ಫ್ರಮ್ ದ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಯಾವ್ಯಾವ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ ಅಲ್ಲ ಅದರಿಂದ ಯಾವ್ದು ಡ್ಯೂ ಟು ವಾಟ್, ವೈ ಎದಕ್ಕೆ ಸ್ಟ್ರಾಂಗ್ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಇದೆ ಅದು, ಬಿಕಾಸ್ ಆಫ್ ದ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ದ ಸ್ಟ್ರಾಂಗ್ ಮೆಟಲಿಕ್ ಬಾಂಡ್ಸ್ ವಿಲ್ ಬಿ ಫಾರ್ಮ್ಡ್. ಕ್ಲಿಯರ್? ಸ್ಟ್ರಾಂಗ್ ಮೆಟಲಿಕ್ ಬಾಂಡ್ಸ್ ವಿಲ್ ಬಿ ಫಾರ್ಮ್ಡ್. Yes, sure. We will solve the model question papers also very soon. Before you people start with your preparatories, we are going to solve it. Okay. Number of unpaired electrons in the d orbitals. So, increases peaks at d5, then it starts decreasing. Means what? The limit is d5. Okay. d5 tanka hogutte means what? It will give the electrons that much. 5 electrons ಕೊಡ್ತಪ್ಪಲ್ಲ, 6 electrons, ಅದಾದ ತಕ್ಷಣ ಜಾಸ್ತಿ ಆಗಲ್ಲ. ಓಕೆ, ದಿಸ್ ಇಸ್ ವಾಟ್ ಇಟ್ಸ್ ಕೆಪಾಸಿಟೀಸ್. ನೆಕ್ಸ್ಟ್, so does the melting point also will trend. According to that, obviously melting point is also going to trend, right? So now what is the exception here is magnesium, that is Mn, and titanium, that is Tc, despite d5 configuration, even though both the elements Mn and Tc, they are having a d5 configuration, means d orbital is having a 5 electrons, they show lower melting points. Okay, even though they have d5, it should be actually high, right? Melting point ಜಾಸ್ತಿ ಇರಬೇಕಪ್ಪ, because electrons ಕಡಿಮೆ ಇದೆ ಅಂದ್ರೆ ಜಾಸ್ತಿ ಇರಬೇಕಲ್ಲ, but also they have a lower melting point. Okay, that is called exceptional. That's what I said you when I started my class. ಯಾವಾಗ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದೆ ಅಲ್ಲ ಕ್ಲಾಸು, ಅವಾಗ ಹೇಳಿದ್ದೆ ನಿಮಗೆ. ಏನು ಹೇಳಿದ್ದೆ ನಾನು? At any cost, guys, at any cost, we are going to get exceptions, right? So, ಈ ಚಾಪ್ಟರ್ ನಲ್ಲಿ ಸ್ವಲ್ಪ ನೆನಪಿಟ್ಕೊಳ್ಳೋದು ಜಾಸ್ತಿ ಇರುತ್ತೆ. So, just make sure you people will write all the points which I am telling you. Okay? So, now despite d5 configuration, they are going to show a low melting point. Clear? Now, Mn configuration is going to be what? Electronic configuration. That is going to be Ar, argon, 3d5 and 4s2. Where d5 is having a 5 electrons because it is having a half filled and stable electron. It will be half filled because there is no electron pair will not be there. There will be only a single electron present in one. Okay. So this is about the Mn configuration. Clear? Done? Done? Understood? Clear everyone? Yes? Next comes what? Enthalpy of atomization. So, enthalpy of atomization is the amount of energy required to break all the bonds in 1 mole of substances. Okay. What is the meaning of enthalpy of atomization? This question has been asked a lot of times for 2 to 3 marks. Okay. 5 marks nalli idne include ಮಾಡ್ಕೋತಾರೆ ಜಾಸ್ತಿ ಟೈಮು. So, don't miss this thing everyone. Okay. Don't miss this thing everyone. Yes, ma'am. Yes, clear? Okay, let's start then. Enthalpy of atomization is the amount of energy. ಯಾವ ತರ amount of energy? The amount of energy which is required to break all the bonds. ಈಗ ಯಾವುದಾದ್ರೂ ಒಂದು ಬಾಂಡ್ ಬ್ರೇಕ್ ಮಾಡಲಿಕ್ಕೆ full amount of energy ಬೇಕು. Even if it is a ionic bonding, then we need more energy only compared to the covalent one, right? So ಬಹಳ energy ಬೇಕು to break that bond in 1 mole of substances. Clear? In 1 mole of substances. Understood? We are breaking the bond in 1 mole of substances, converting it into the individual gaseous atoms. We are converting that into the individual gaseous atom. Gaseous atom nalli individually we are separating them. That is actually called as what? Enthalpy of atomization. Clear? Clear? Definition is very important. Try to understand this concept properly. The breaking down of a bond in 1 mole of a substance is converting it into the individual gaseous atom. Clear? Done? Next. Transition elements have a high enthalpies of atomization because their atoms have a large number of unpaired electrons. They have what? Large number of unpaired electrons. Clear? They have a large number of unpaired electrons. Because of that, in their d orbitals, this all transition elements will be having a high enthalpies. They all will be having a high enthalpies. Clear? So transition elements yavaglu high enthalpy atomization alli irutte because there will be having a what? Large number of unpaired electrons in the d orbitals. Clear? So this is also a give reason. Give reason type question iduno nenepitkolli important. This is also important. Clear? Write it down everyone. Let's see how many people will answer. Clear everyone? Come on. Understood? Next comes what? This unpaired electrons participate in the strong metallic bonding. So, ivella unpaired electrons eniruttalla means which are not included in the transition elements. Those all things that these unpaired electrons will participate in the strong metallic bonding leading to the strong interatomic interaction. Enaguttili strong interatomic interaction is possible. Why? They have unpaired electrons, but the unpaired electrons enagutte? They need to go and attack somewhere, right? It's not like that. If they are not satisfied, they have not become still Ambani, then they are going to go and work. Okay. Now Ambani agbittandre mane kuntevappa. Ambani agilla andre hog work ಮಾಡ್ತೇವಲ್ಲ. We will work, right? You people are also learning to get good job in your future, right? Same ಅದೇ ತರ ಇತರದ್ದು unpaired electrons ಇದೆ. ಇನ್ನ unpaired electrons ಇದೆ. Electrons ಇನ್ನ satisfy ಆಗಬೇಕು, ಹೋಗಿ ಆರಾಮಾಗಿ enjoy ಮಾಡಬೇಕಂದ್ರೆ they need to go and work. So they are actually going and interacting. Strong interatomic interaction is happening in between the electrons. Clear? So the unpaired electrons participate in the strong metallic bonding. Strong metallic bonding ನಲ್ಲಿ participate ಮಾಡುತ್ತೆ, which will actually lead to the strong interatomic interaction. Clear? So and high energy requirement to break these bonds. So to break these bonds also we need very high energy. Why? Because if we have bonded, okay, nimdu yavaru best friends idarappa, okay, this you people have a best friends, our best friends with friendship murilike ಸ್ವಲ್ಪ time ತಗೊಳುತ್ತೆ, right? So it's not like immediately if we will some chugli ಒಂದು ಹೇಳ್ಬಿಟ್ರೆ ಏನೋ ಅವ್ರದ್ದು ಇವಳ್ದು ಯಾವ್ದೋ ಈಕೆ ಹಂಗಂದ್ಲಪ್ಪ ನಿನಗೆ ಇವಳು ಹಂಗಂದ್ಲು, ಸೊ ಅದನ್ನ ಹೇಳ್ಬಿಟ್ರೆ ಬ್ರೇಕ್ ಡೌನ್ ಆಗುತ್ತೆ ಅಂತ ತಿಳ್ಕೊಬೇಡಿ. It won't. Okay, we need some time. They will be having a very much trust issues also, right? So if full trust ಮಾಡಿರ್ತಾರೆ ಇಬ್ರು best friends ಅಂದ್ರೆ 100% sure they won't break themselves, right? Why? Because they have a very strong connection, right? It means what? They have a very strong interatomic interaction. So if they both have an interatomic attraction very strong, it's very difficult to break them. Clear? Next comes what? Enthalpy of atomization mein the metals of the second and the third series have a stronger metallic bonding than the corresponding elements of the first series. So whatever the metals are present in the second and the third series, they have a strong metallic bonding. They have what? They have a strong metallic bonding and corresponding elements of the first series. They have a corresponding elements of the first series also. Now because of that, because of these things only, this is very important factor in accounting for the need of prepare data on the free atoms of the metal compounds of the heavy transition metals, Because of that, stronger metallic bond will be there, greater number of unpaired d electrons will be there. For that purpose only, stronger metallic bonding will be there. Metallic bonding will be completely be stronger and the greater number of unpaired d electrons also will be there. So unpaired electrons in the d block elements will be greater, more. Okay, ಜಾಸ್ತಿ ಹಾಕೊಂತ ಹೋಗುತ್ತೆ. Next comes what? Increased cohesive interaction also will be there. Increased cohesive interaction means what? So a reaction between the two electrons in unpaired electrons ಇರುತ್ತಲ್ಲ, ಅವತ್ತದೆಲ್ಲ reaction ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಹಾಕೊಂತ ಹೋಗುತ್ತೆ. It will become more and more. Clear? Understanding? Say yes if you have understood it. Okay. More extensive valence d orbital interaction will be also be there. So the extensive valence d orbitals also of interaction also will be more and more. So the third series transitions elements have a stronger interatomic interaction. So the third series which is there, the transition elements will have a very strong interatomic interaction. So you should remember only one thing. Okay. Ee second ಮತ್ತು third nalli the third series will be having a good compared to the second one. Clear? So enthalpy of atomization ನಲ್ಲಿ ಏನೇನು ನೆನಪಿಟ್ಕೋಬೇಕು? First is the definition of it, right? So ಏನು definition ಅದು? Amount of energy which is required to break all the bonds in 1 mole of substances and that converting them into the individual gaseous atoms. The definition you should remember, first thing. Next you should remember about the transition elements which are there highly high enthalpy of atomization irutte. So ivella points ana chennagi note down madಕೊಳ್ಳಿ. These points are very important. Clear? Tilita? Yes. Ma'am, neat class ಮಾಡಿ ma'am please. Yes, we will do the neat class also, don't worry. We will start with the neat classes also. Amma, almost I think the neat classes ಎಲ್ಲ chapters na ಮುಗಿಸಿದ್ದೇನೆ second year ದು. If you go and check this out also fast. Okay. So I am saying that many people have not marked up your attendance also. Fast agi mark ಮಾಡಿ attendance anna, because I can just see that you people have not marked your attendance. Hit the like button, then only I am going to get that you are seeing my classes here. Okay, fast agi hit ಮಾಡಿ. Okay. Okay, then let's go to the next part. That is going to be the question related to that. Why enthalpy of atomization of a magnesium is low? Okay, so magnesium do yakappa, why enthalpy of that atomization of magnesium is very low? ಯಾಕೆ ಕಡಿಮೆ ಇದೆ? Okay, so ಈಗ magnesium, which is also called as Mn, has a lower enthalpy of atomization than accepted. Okay, ಇದು actually already ಕಡಿಮೆ ಇದೆ, right? We have learned it already. ಎಲ್ಲಿ ಹೇಳಿದೆ ನಾನು? So this is actually having a low melting point. Okay, it is already having a low melting point. We have learnt it already, right? It's not a new thing to you, right? So ಏನು ಹೇಳಿದ್ದಾರೆ actually? What they have actually asked the question is, ಅದು atomization of magnesium ಯಾಕಪ್ಪ ಕಡಿಮೆ ಇದೆ? So that time it is having already the enthalpy of atomization, then they accepted due to the stable quantity. Means ಭಾಳ stable ಇದೆ. It doesn't care. Men is like what, you know. So ಏನು ಮಾಡ್ಕೋತಾರೆ ಮಾಡ್ಕೊಳ್ಳಿ, ನಂಗೆ ಕೊಡೋರಿದ್ರೆ ಕೊಡಿ, ಎಲೆಕ್ಟ್ರಾನು ಬೇಡ ಅಂದರೆ ಬಿಟ್ಬಿಡಿ. I don't care. I am happy. I am stable with whatever we have. Okay. ಸ್ವಲ್ಪ ಮಂದಿ ಇರ್ತಾರೆ, ನನ್ನ ಕಡೆ ಎಷ್ಟಿದೆಯಪ್ಪ ಅಷ್ಟರಲ್ಲಿ ನಾ ಖುಷಿ ಇಡ್ತೇನೆ ಅನ್ನೋದು. ಸ್ವಲ್ಪ ಮಂದಿ ಇರಲ್ಲ. ಸ್ವಲ್ಪ ಮಂದಿ ಏನಿರ್ತಾರೆ ಅಂದರೆ ನಾನು ಇನ್ನ ಜಾಸ್ತಿ ಗಳಿಸ್ಬೇಕಪ್ಪ, ನಾನೇನೋ ಜಾಸ್ತಿ ಇದನ್ನು ಮಾಡಬೇಕು, ಐ ನೀಡ್ ಟು ಡೂ ದಿಸ್, ಐ ನೀಡ್ ಟು ಡೂ ದ್ಯಾಟ್. ಸೊ ಅವನ್ನೆಲ್ಲ ಮಾಡ್ಲಿಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತಾರೆ, ರೈಟ್? ಲೈಕ್ ವಿ ಆರ್ ಆಲ್ಸೋ ದೋಸ್ ಥಿಂಗ್ಸ್, ರೈಟ್? ಸೊ ನಾವು ಈಗ atomization, then they accepted due to its stable half-filled d orbital configuration. Clear? So this Mn configuration d block element nalli almost it is having only 5. Means what? 10 nalli half ide. Okay, it's there already half, right? So it is actually half filled. Okay, d orbital is half filled, right? For that purpose it is having a lower enthalpy of atomization. Okay, this stable configuration means what? D electrons are tightly held by the nucleus. Means what? It's not giving. I told you people, more than d orbital nalli 5 ginta kadame agalla. Most lastly it is going to go till d4. More than that it's not going to go. Okay, so ಈಗ d5 ಇದೆ ಏನು? It's like in the between. Okay, ನಾನು full rich illa, ಈಗ ನಾನು full poor illa. Okay, in between we are middle class. Okay, so now middle class person, what he will do? That person, that element, the Mn element, which is actually a middle class, that will actually have a lower enthalpy of atomization. For that purpose they will be having a stable configuration. Clear? That's what I'm trying to tell. Stable configuration irutte, right? So and the d orbitals are tightly held by the nucleus. Means what? So it will be tightly held, means it has a good support of the family. Okay, it has a good support of the family. Mn is actually stable and it has a good family support also. Simple. ee tara ನೆನಪಿಟ್ಕೊಂಡ್ರೆ easy ಆಗಿ ನೆನಪುಳಿಯುತ್ತೆ. Clear? So they don't readily participate in the metallic bonding, and they will not participate completely in the metallic bonding. readily means what? It means what? Something unique. ಹಿಂಗೆ ಯಾವ್ದಾರದು ಒಂದು ಮಿಡ್ಲ್ ಕ್ಲಾಸ್ ಇದೆ, ಯಾವುದು ಎಲ್ಲೋ ಏನೋ ಮಾಡಬಾರ್ದಪ್ಪ ನಾನು, ಅದು ಅಲ್ಲಿ ಏನೋ ಮಾಡಬಾರ್ದು, ಇದು ಏನೋ ಆಗಬಹುದು, ಓಕೆ, ಆಗಬಹುದು, ಏನಾದರೂ ನಾನ್ಸೆನ್ಸ್ ಆಗಬಹುದು, ಸೊ ಅದಕ್ಕೆ ಮಾಡಬಾರ್ದು ಅದನ್ನು, ರೈಟ್? ಎಸ್, ಅದನ್ನು ಮಾಡಬಾರ್ದು ಅಂತ ನಿಮ್ಮ ತಲೆಯಲ್ಲಿ ಇರುತ್ತೆ, ರೈಟ್? ಸೇಮ್ ಅದೇ ಥರ ಇಲ್ಲಿ ಮೆಟಲಿಕ್ ಬಾಂಡಿಂಗ್ನಲ್ಲಿ ದೇ ವಿಲ್ ನಾಟ್ ರೆಡಿಲಿ ಪಾರ್ಟಿಸಿಪೇಟ್ ಇನ್ ದೋಸ್ ಆಫ್ ದ ಥಿಂಗ್ಸ್, ಓಕೆ, ಅನ್ನೆಸೆಸರಿ ಥಿಂಗ್ಸ್ನಲ್ಲಿ ಪಾರ್ಟಿಸಿಪೇಟ್ ಮಾಡಲ್ಲ, clear, resulting in the weaker metallic bonds and hence lower enthalpy of atomization. So it will be having what? Lower enthalpy of atomization, clear? So it will be having a low. That's what we told in the first sentence itself. Clear everyone this question? This question is also very important. Na yalla questions repeat agirod tagondidene, don't miss them, all questions. Just take a screenshot if you want it. After the class the notes also will be available. ಈಗ ಸದ್ಯ ಮಾಡೋದಿದೆ ಅಂದರೆ ಬರ್ಕೊಂತು ಹೋಗ್ಬೋದು, ನಾ ಕಲ್ಸೋದು ಮುಂದೆ ಎಷ್ಟು ಲೈನ್ ಟು ಲೈನ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತಿದ್ದೇನೆ. ಯು ಕ್ಯಾನ್ ರೈಟ್ ಇಟ್ ಟಿಲ್ ಐ ಎಕ್ಸ್ಪ್ಲೇನ್ ಆಲ್ಸೋ, ಓಕೆ? So next question, next topic, that is going to be the atomic size. So this is also very important topic. Idu completely it will be focused, means on this KCET ನಲ್ಲಿ sure ಆಗಿ question ಬೀಳುತ್ತೆ. We are going to get a KCET में question from the atomic size also, okay? Done? Yes. Let's start. Atomic radius from left to right, okay? ಈಗ ಏನ್ ma'am left to right? That's what I told you. We want a periodic table here, okay? From left to right, I don't know, I'm standing right now here, this is my right and this is my left. So from left to right, whichever it's going on, whichever it is there, nim left right yavudiದೆ ನೋಡ್ಕೊಳ್ಳಿ ನೀವು, okay? From left to right, initially decreases, then remains constant and finally increases. So what is happening with the elements here? From left to right, all the elements which are present here, first in atomic size of initially it will start decreasing. Initially it will start decreasing. Starting nalli decrease akonta hoಗುತ್ತೆ atomic size, okay? Atomic size, what will happen? So initially ಇಲ್ಲಾಂದ್ರೆ ಸ್ಟಾರ್ಟಿಂಗ್ ಅಂತ ಹಾಕ್ತೇನೆ, starting it will decrease. Done? So starting it will decrease, then remains constant, then slowly it will start remaining constant still little bit, okay? Start like constant irkonta hogutte and finally it will start increasing. It means what? This you people remember enough. ಇದನ್ನ ನೆನ್ಪಿಟ್ಕೊಂಡ್ಬಿಡಿ, ಈಸಿ ಆಗುತ್ತೆ. ಎಲ್ಲ ಸೇಮ್ ಕಲರ್ ಆಗಿಬಿಟ್ಟಿದೆನಾ? ವಿಲ್ ಚೇಂಜ್ ದ ಕಲರ್, ಓಕೆ? ಸೊ ಸ್ಟಾರ್ಟಿಂಗ್ ನಲ್ಲಿ ಏನಾಗುತ್ತೆ? ಇಟ್ ವಿಲ್ ಅಟೋಮಿಕ್ ಸೈಜ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಡಿಕ್ರೀಸ್ ಫ್ರಮ್ ಲೆಫ್ಟ್ ಟು ರೈಟ್. ಬಿ ಆಕ್ಟಿವ್ ಇನ್ ದ ಚಾಟ್ ಬಾಕ್ಸ್ ಎವ್ರಿವನ್. Yes. So now see, you can consider properly here, from left to right according to the periodic table, the atomic size is going to start decreasing, then it will remain constant and then start increasing. I think we have one, I'll draw you and show you the graph also if you want. So it's visible properly? Oh no, the color is not visible, huh? So ಇದು ಗ್ರಾಫ್ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ, just for information I'm giving you. So first ಏನಾಗುತ್ತಪ್ಪ, this is actually atomic size. Okay, first increase ಆಕೋಂತ ಹೋಗುತ್ತಪ್ಪ, ಆಮೇಲೆ it will remain constant and then it will increase again. Okay, first it will decrease actually. First it will start decreasing. Okay, first it will start decreasing like this. Okay, it will be decreasing, then it will remain constant like this and then it will start increasing. Okay, this is how the atomic size is going to work. Atomic size from left to right in the periodic table. Clear? PT andre PT ತಿಳ್ಕೊಬೇಡಿ, PT means periodic table. Clear? It's a periodic table. Done? Yes, this is how you can remember about the atomic size. Clear? So first decrease agutte, ಆಮೇಲೆ constant ಇರುತ್ತೆ, ಆಮೇಲೆ increase agutte. Now next comes lanthanide contraction refers to the gradual decrease in the atomic and ionic radii of the lanthanide elements. Clear? So how you should remember now? Lanthanide contraction, it will completely refer to a gradual decrease. Gradual decrease means what? It will start decreasing. So in the atomic and the ionic radii of the lanthanide elements. So lanthanide elements nalli decrease akonta hogutte in the basis of the atomic and the ionic radii. Clear? And as the atomic number increases from the lanthanide to the lithium. So what happens here? The atomic number also will start increasing from the lanthanum to the lithium. Okay? From the lanthanide to the lithium. Now this unaccepted size reduction occurs because of the 4f electrons. Because of what? Because of the 4f electrons. The increasing, decreasing, constant, all these things are happening because of the 4f electrons. So E4f electrons which are present, this is being added. Okay, it's being added to the inner shells of these elements and are not very effective at its shielding the outer electrons from the increasing the positive charge of the nucleus. How positive? We are giving up the electrons, right? So at the salvagi positiveness baratte. Why? Because we are giving up the electrons. Clear? So this unaccepted size reduction is happening. Why? Because of the 4f electrons. Okay? Because of this 4f electrons which are present there, these all are being added to the inner shells. So inner shells nalli hakonta hogutte. We knew already how the atomic idu nucleus tilkondre, these are all idu tilkoli S P ಇದು ಡಿ. ಸೊ ಏನು ಎಸ್ ಪಿ ಡಿ ಎಫ್ ಇದೆ ಅಲ್ಲ ಕಂಪ್ಲೀಟ್ಲಿ ಅವೆಲ್ಲ ಇನ್ಕ್ರೀಸ್ ಹಾಕೊಂತ ಹೋಗುತ್ತೆ ಬಿಕಾಸ್ ಆಫ್ ದ 4f electrons. Clear? So this 4f electrons which are present, that will be added to the inner shells. They will be added to the inner shells. Clear? And are not very effective at the shielding the outer electrons from increasing the positive charges. Means what? It will not protect. Okay, it's not that much protective, it's not shielding. Shielding is already gottide, not necessary to explain. Shielding agodu ಏನು ಇರುತ್ತಲ್ಲ ಅದು ಅಷ್ಟು ಪ್ರೊಟೆಕ್ಟ್ ಮಾಡಲ್ಲ. It won't protect that much. Okay, it will be like do whatever you want, I'm going to do what we want. Okay, so ಆ ಥರ ಇದು actually elements 4f electrons. Clear? So it's not going to go to inertia also, it's not going to help us out also. Clear? So this is how it's going to work out. Okay. Next comes the ionization enthalpies. Okay, now you need to be perfect with the atomic radii, because on atomic radii, short 1 KCET question is going to be asked. So please be prepared for that. Okay, so let's start. We will see the questions at the end of the class. Make sure you will be there till the end of the class. Okay, now ionization enthalpies, generally first ionization enthalpy, that is IE1, increases from left to right. Okay, ionization enthalpy will start increasing from left to right across the d block series due to the increasing effective nuclear charge. Why? Because the increasing effective nuclear charge is there. Okay, effective agi nuclear charge increase akonta hogtide ionization energy nalli, ಅದರ ಸಲುವಾಗಿನೇ effective, the nuclear charge will be more effective. Right? So ಇದು ಏನು ಕೆಲಸ ಆಗಬೇಕಲ್ಲ ಅದು ಕೆಲಸ ಆಗ್ತಿದೆ ಅನ್ನೋ ಆಗೋ ಟೈಮ್ದಲ್ಲಿ it will be happy. Right? So ಈಗ ಏನೋ ಒಂದು ಇನ್ಕ್ರೀಸ್ ಮಾಡೋದಿದೆಯಪ್ಪ, we want to increase it, we want to give the electrons, we want to fill all the d orbitals, we want to fill all the f block elements. So ಇವೆಲ್ಲ ಏನೋ f electrons, so ಇವನ್ನೆಲ್ಲ fill ಮಾಡೋದಿದೆ completely ಅಂದ್ರೆ it needs to be supported. Right? It needs to support. If this will not support, then how we can increase it? Right? So that is what the support is necessary. Now, however, this increase is not always smooth with some irregularities. So why? Because whatever these things are happening, whichever we are helping them to complete their octet, that time what it is happening, that is not going to go smoothly. Okay, irregularities antu elladrallu barutte, enadru on difficulty baruttalla. So idralli inu enadru madok mundu difficulties, irregularities are possible. And what are those factors? That is about the electronic configuration, that is IE1, that is ionization energy, generally increases from the first to the third ionization enthalpy. It's actually coming from what? First to the third. First to the third ionization enthalpy for the given element. For the given element, ionization energy is going to start increasing from first to the completely with the third one. Okay, first in the third ionization enthalpy hogutte yav element kottidira depends on that, it is going to change it. Remember it, don't forget the words there. Okay, exceptions ಏನidappa idralli chromium, that is Cr, which is having a lower ionization energy due to what? Half filled DF configuration. Means what? In D orbital it's completely half. Okay, D5, it is like a magnesium itself, Mn, it's just like a Mn, it's completely half filled. That is going to be what? DF configuration. Clear? Next comes the copper, that is Cu. Here what happens? Lower ionization energy due to the stable D10 configuration. Because of what? Stable D10 configuration. D orbital completely stable ide. Clear? Next comes the zinc, that is relatively high ionization energy, has removal of a 4s electrons. Because of what? Because of the removal of the 4s electron, it leads to the stable 3d10. Okay, zinc actually relatively it is having a high ionization energy. Okay, but it has been removal, means 4s electron has been removed completely. For that purpose, that will lead to what? Completely filled D10 orbital. Okay, completely filled D10 orbital. So that also can be considered. Clear? Clear everyone? Understood this? Yes. Let's move to the next. That is going to be the oxidation state. Okay. Oxidation state shows variable oxidation state. Exception is going to be the Sn and Zn. So D block elements are also known as transition metals also. So all these D block elements are also going to be considered as transition metals. Now understand here properly. Shows the variable oxidation state. So variable oxidation state yavag torstide adu? When it is showing the variable oxidation state, when the exceptional are going to be the Sn and Zn. Clear? Understand? Here I have given few of them. Elements ide. SC. Oxidation state is going to be the +3. Here the titanium, that is Ti, +3 and +4 has its oxidation state. V, which is having +2, +3, +4 and +5. Cr, chromium, C +4, +2, +3 and +6. Mn also +2, +3, +4 and +4, 7 also. Iron +2, +3. Cobalt +2, +3. Ni also +2, +3. So these are also the electronic oxidation states which you people need to remember them. Okay, which you should remember it properly. Ma'am, hi Arman, why you are late, so much late to the class? I am repeating it, concentrate now. Okay, shows the variable oxidation state except the Sn and the Zn. So this is the exceptional here. How you should remember? In oxidation state, it will show variable oxidation state to ella through the living these elements. Living these elements all will show the variable important. Okay, so all will show the variable oxidation state. Clear? Yes, it is enough for the boats. Okay, it is enough for the boats. Now, next comes what? D block elements, also known as the transition metals also, because they exist a wide range of oxidation state. Because it will exist a wide range of oxidation state due to the involvement of the Ns and N-1d electrons. Because of what? Due to what? There will be an involvement possibility. Ide yathard involvement possibility there. Ns matte N-1d. This is general equations. Okay. So Ns matte N-1d electrons in the chemical bonding, it's been involved. For that purpose, the oxidation state involvement means whatever the wide range of oxidation states are there, that involvement both of Ns and N-1d electrons in the chemical bonding. In the chemical bonding. Clear? Clear? Crystal clear? Huh? Very good. Crystal clear? Yes, these elements can show the multiple oxidation state, with the most common ones being going to be the +2 and +3. That's what I told you. Most of them have a +3, +3, +2, +2, +2, +2, +3s are there also. Here you can just observe everywhere the oxidation states are most probably the +2 and +3 itself. Means what? It's trying to give the electrons 2 or 3. Okay. Here the more electrons transfer okay. This is how it's going to work out, oxidation state. So from oxidation state also they might ask the exceptional. What we have learnt exceptional here, first thing is that leaving this Sn and Zn, all will show the variable oxidation state. Clear? All will show the variable oxidation state, leaving Zn and Sn and Zn. Clear everyone? Done. Next comes the magnetic properties. Now, magnetic properties of transition elements arise due to the presence of unpaired electrons. Due to the presence of unpaired electrons in their d orbitals, the magnetic properties of the transition elements will arise. Magnetic properties of transition elements will start arising due to its presence of unpaired electrons. I'll mark it in their d orbitals. Okay, the magnetic moment is calculated using the formula, that is mu. This is also very important, guys. How the magnetic moment will be calculated? That is going to be what? Mu n. So root of n plus 2 bm, okay, where n is going to numbered as a number of the unpaired electrons. So n is going to consider how much? So what is the number of the electrons, unpaired electrons, that we are going to consider it. Done. Next comes what? Types of magnetism. Types of magnetism. We have three types here: paramagnetic, diamagnetic and ferromagnetic. Okay. Now we have learnt, means in hybridization and all, we have learnt that how we are going to name them with the help of the magnetisms. Means which is a paramagnetic, which is a diamagnetic, which is a trimagnetic. This all things we have learnt it. Now let's learn it according to the elements. Okay. How it's going to be now? Types of magnetism. Just once again. Yes. So in types of magnetism, before that you need to have a perfect idea about this thing, that is magnetic moment, how you are going to calculate it. Just remember this formula perfectly. Okay. Remember this formula perfectly, full on. Okay. Next comes what? Types of magnetism, where the paramagnetic is there, diamagnetic and ferromagnetic. First we will learn about the paramagnetic now. Elements with unpaired electrons which are there, then attracted to magnetic field, which are attracted to the magnetic field. Example, Fe3 plus and Mn2 plus. Fe3 plus and Mn2 plus examples we can take it for the paramagnetic. Clear? So elements with unpaired electrons are all called as what? Paramagnetic. ಈಗ ಯಾವುದಾದ್ರೂ ಒಂದು electronic configuration ಇದೆಯಪ್ಪ, ನೀವೆಲ್ಲ ಚೆಕ್ ಮಾಡಿದ್ರಿ, ಅಲ್ಲಿ ಅಕಸ್ಮಾತ್ unpaired electrons ಇದೆ, electrons has been not paired, okay, there are single electrons present, that all things are going to be considered as a paramagnetic. Clear? Understanding? Yes. Next comes what? Attracted to magnetic field. So these are all attracted to the magnetic field. Examples also they have given, that is Fe3 plus has its oxidation state and Mn2 plus has its oxidation state. Clear? Next comes the diamagnetic, elements with all the electrons which are being paired. Concentrate. Diamagnetic and ಏನಪ್ಪ, which are paired completely. Electrons which are paired are called as diamagnetic. Done? So weakly repelled by a magnetic field. Weakly repelled by the magnetic field means what? The attraction is not so strong like a paramagnetic. The attraction between the elements, electrons are not that strong. Clear? So examples we can give it at what? Zn2 plus and Cu plus. Okay? Zn2 plus and Cu plus we can give as a example. Clear? Yes, very good, Dev. Okay, okay, mama. What is okay, okay, ma'am? Okay. Cool. Done. Next comes the ferromagnetism. Okay, what is the meaning of a ferromagnetism? It is the strongest form of a magnetism. It is completely a strongest one of a magnetism. Like what? Compared to the diamagnetic and paramagnetic, it's going to act a very strongest one. Okay, like example, it is the strongest form of a magnetism. Materials retain magnetic movement even after external field is being removed. Okay, materials will retain the permanent magnetic movement even after external field is been removed. Then also it's going to act like a magnet. It's going to act like a magnet. Clear? Done? So in this magnetic properties, you should remember about the magnet, how to calculate the magnetic moment. That is mu is equal to root of, I'll draw the root here. Okay, root of mu is equal to root of n plus 2 bm. That is going to be what? N is going to consider as what? Number of unpaired electrons. It's going to consider as what? Number of unpaired electrons. Done? Clear everyone? Clear with these things till here? Everyone clear with these things till here? ಯಾರ್ಯಾರು ತಿಳಿದಿಲ್ಲ ಹೇಳಬಹುದು. Okay, let's move to the next part, that is going to be the magnetic properties of D block elements. So let's move to the magnetic properties of D block elements. Clear? Now, most of the D block elements are paramagnetic due to the presence of unpaired electrons in their D orbital. In their D orbital, most of the D block elements are going to act like a paramagnetic. Why, ma'am? Why it is going to act like a paramagnetic? Why? Because most of the D orbitals are going to be the unpaired itself. Electrons are unpaired. For that purpose, we are going to consider them as a paramagnetic. Clear? So now the magnetic moment is calculated by using the formula mu. This we know it already, right? That is what mu is equal to magnetic moment root of n. Once again, root of n plus 2 bm, where n is going to be considered as number of unpaired electrons. Yestappa unpaired electrons ideyala, just substitute madodu, will get the answer. Clear everyone? Let's see next one, that is formation of colored ions. What is the meaning of a formation of a colored ions? Okay, now colors are also very important. Okay, yav compound to yav color there, and when that element is going to be included in other element to form that compound, then what is the color is being formed, and according to the color, means yav color there, atra prakaranu we can decide whether the atomic size is increasing, decreasing, or anything like ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಅಂತೂ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೋಬಹುದು. ಸೊ ಈ ತರ ಫೈಂಡ್ ಮಾಡ್ಕೋಬಹುದಾ ಕಲರ್ಸ್ ಇಂದ ಅನ್ನೋದು ನೋಡೋಣ. ಆಯ್ತಾ? ಕ್ರಿಸ್ಟಲ್ ಕ್ಲಿಯರ್ ಟಿಲ್ ಹಿಯರ್? Crystal clear till here? Yes? Yes, let's move then. Formation of colored ions. The formation of colored ions is due to the presence of unpaired electrons. It's because of what? Unpaired electrons. Now, in the d orbital, and the dd transitions occurs when the electrons jump from one d orbital to the another. When it's going to jump from where? One d orbital to the another. Clear? So the formation of this colored ion is due to the presence of the unpaired electrons. This is also very important concept in the form of KCET and PU board. Okay, yakappa important ide, yakappa namage color changes irutte, we need to understand that, right? Color changes ಬಗ್ಗೆ ಗೊತ್ತಾಗಬೇಕಲ್ಲ. Hi Basan Gowda. So, the formation of the colored ions is actually due to the presence of the unpaired electrons. So, ಏನಪ್ಪ unpaired electrons presence ida? ಈಗ unpaired electrons ಎಲ್ಲಾದರೂ ಇದೆ. Okay, we have unpaired electrons somewhere. Okay, so that unpaired electrons which are present, no, there all the colors are going to be shown. Okay, now the dd transition occurs when the electrons jump from one d orbital to the another. So one d orbital to the another, if it is jumping, okay, one d orbital to the another, it is jumping, then within the same energy level. Energy level will be same, only d orbital will be 1 only. No, it's not like we have a different, okay. We have only one, in that only energy level, it's just moving. It means jumping from one place to the another. That dd transitions occurs when the electrons will jump from d orbital to the another within the same energy level. That is actually called as dd transition. Okay, and these transitions observe visible light and the complementary color is being observed. See, this transition ago time nalli, when the electron is being jumping from one place to the another in the same energy level only. See, example I am telling you. See, ivella energy level tilkoli. Okay. These are all same energy levels, okay. Now, one thing you should remember here is, this energy level in the energy level ge bantappa, okay. When this visible, that time what happens, when this energy is been, this electron has been jumping from one more place in the same energy level. This is same energy level, okay. This is same energy level itself. This transition observe visible light and the complementary color is being observed. Means what? This transition the light will observe what? Visible light. Okay. Visible light will be observed and the complementary color is also being observed. So, avaga color barutte. Color will be coming at that time. Clear everyone? Understanding? Understanding? Done. Next comes what? Number of unpaired electrons. Now the color is going to be depended on. Okay. Now how the color is going to be depended on? Okay. Now how the color is going to be depended on? It depends on the number of unpaired electrons. It's going to completely depend on the number of the unpaired electrons. Clear? So, yav tara unpaired means unpaired electrons 1 iruttappa. 1 will be there. Sometimes it will be 2. Sometimes it will be 4 unpaired electrons. Because it depends on it. No, whatever the electronic configuration, then it depends on that. Right? Say the number of electrons, unpaired electrons, yes, athir mele yav color visible of light is yes, avag gottagatte. Clear? And next one is oxidation state of a metal ion, whether the oxidation state is +2, +3, +4, +7 thananu ide. So plus 7 yavud iruttalla adu depended on that the color is going to be seen. Next comes the nature of the ligands attached. So how much of the ligands is being going to attach. So yav tara ligand attach ide adar melenu color depended agutte. So what will be the color? That will be depended on the nature of that also. Okay. Next comes what? Geometry of the complex. So what is the geometry of the complex? If we have taken one complex, okay, we have taken one complex, in that what is the geometry? Okay, yav tara geometry ide adu adar melenu color distribution agutte. Done. So sometimes what they will tell, even I'll simple example heltene, textbooks nalli actually diamonds anna sky blue color nalli tostare. Okay, so but usually if you see the natural diamond, it actually looks, the visibility of the light is visibility of the diamond is actually sky blue little bit, but it will be visible sometimes in the form of what? White also. It will be visible in the form of white. So that time, no, this is what chemistry will come there. Okay. Next comes what? Ions with fully filled or empty d orbitals will be there, and ions with fully filled or empty d orbitals means what? Sometimes it will be D10. Okay, it will be, sometimes it will be D10, sometimes it will be what? Completely be empty only. Okay, sometimes it will be completely be empty only when it is going under the oxidation state. Okay, when it is going under the oxidation state, that will be, sometimes it will be empty, right? So oxidation state ಅಲ್ಲಿ ಹೋದ್ರೆ empty ಇರುತ್ತೆ, ಆ ಟೈಮ್ದಲ್ಲೂ color difference ಬರುತ್ತೆ. Clear? So ಅದ್ರ ಸಲುವಾಗಿ ಹೇಳ್ತೇವೆ, if we are taking some colors and we are adding up it in somewhere, okay, we are adding it and we are doing some experiments, that time it's going to work. Done? Yes. Next, formation of interstitial compounds. Formation of interstitial compounds. Now here what happens? Transition metals from interstitial compounds with small atoms like H, like hydrogen, B, C, N. These small atoms will occupy the vacant spaces. These will occupy what? Vacant spaces, that is intersectives in the metal lattice. Now this transition metals will form the intersective compounds. Okay, with small atoms, yakapa small atoms ivella andre idu atomic numbers small irade. Okay, it has a very less electrons. It might give electrons, sometimes it might take the electrons easily. For that purpose we are going to take the small atoms. Okay, illappa ee sala NEET exam stuff ag baralla. It will be very easy. Pray for the God. Okay, it will be very easy, don't worry. So these small atoms will occupy the vacant spaces like intersectives in the metal lattice. So you will again spaces iruttappa. Okay, we have a lots of spaces in between the elements. Okay, in spaces idella, this all spaces will be filled by these electrons. Okay, by these elements. Okay, so ivella elements, so they might come and occupy the spaces in between those lattice energies. Done? Understood? Next, characteristics in barate yavag intersexual compounds form aguttalla. What will be the characteristics? Now, non-stereochemical in nature, it will be non-stereochemical in nature, and then the neither ionic nor it will be covalent. Okay, neither ionic irutte, but sometimes it won't be a covalent also. Okay, neither ionic nor covalent andre you have to bonding iralla. Done na? Next. Examples yav tagobodu TIC, MN4N, Fe3H, TiH2. These are the few examples which we can take it easily. Done. So next comes the effect of metal properties. Effect on metal properties. So metallic properties mele yav tara effects agutte. First one is what? Increased hardness and the rigidity. So increased hardness means what? Hardness will be increased. How much ever you are doing something, the hardness will start increasing. Okay. Best example ಹೇಳ್ತೇನೆ, ಯಾರಾದರೂ ಸೌತ್ ಕರ್ನಾಟಕದಲ್ಲಿ ಇದ್ರೆ ಯು ಕ್ಯಾನ್ ಗೋ ಜುನ್ಕ ಅಂತ ಮಾಡ್ತಾರೆ. ಒಂದು ಜುನ್ಕ ಇಸ್ ಅ ಫುಡ್. ಓಕೆ, ಸೊ ಆ ಜುನ್ಕಾನ್ ಏನು ಮಾಡ್ತಾರಲ್ಲ, ಎಷ್ಟು ನೀವು ಬಿಸಿ ಮಾಡ್ಕೊಂತ ಹೋಗ್ತಾರಲ್ಲ, ಇವನ್ ದೋ ನೀವು ನೀರು ಹಾಕಿ ಹಿಟ್ಟು ಹಾಕಿ ಏನೋ ಮಾಡಿ ಅದನ್ನ ಬಿಸಿ ಮಾಡ್ಕೊಂತ ಹೋದ್ರೆ ಗಟ್ಟಿ ಹಾಕೊಂತ ಹೋಗುತ್ತೆ. ರೈಟ್, ಸೇಮ್ ಇಟ್ಸ್ ಲೈಕ್ ದ್ಯಾಟ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ higher melting points than the pure metals. Higher melting points than the pure metals they are. So retain metallic conductivity. It will retain to the metallic conductivity also, and chemically it is inert also. Chemically it is inert, and some bodies are as hard as diamond. Okay, some bodies are actually as hard as diamond. Just imagine. So diamond ಎಷ್ಟು hard ಇದೆ ಅಲ್ಲ, ಅದ್ರ ತರಾನು some elements ಇದೆ D block elements ನಲ್ಲಿ. So ಅದನ್ನ full ಆಗಿ hard ಇರುತ್ತೆ. Clear? Done? Yes. Next comes the traits in M2 plus and or M standard electrode potential. Traits in M2 plus and M or M standard electrode potential. Now E0 values of M2 plus or M across the first transition series are generally it's going to be the negative. It's generally going to be what? In transition elements, it's going to be the zero itself, negative itself. Okay, now indicating that this metals can liberate, it can start liberating H2 gas. It can start liberating H2 gas from dilute acids. From the dilute acids, they can liberate H2 gas. They can liberate the H2 gas from the dilute gases. Clear everyone? So the trend is influenced by enthalpy of atomization. We have already learnt it. What is the meaning of enthalpy of atomization? Next, it is going to depend on ionization enthalpy also. And the last one, that is hydration enthalpy also. Clear? Clear everyone? So, ಈಗ ಎದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. The E0 values of this M2 plus oxidation state or M across the first transition series. First transition series ನಲ್ಲಿ generally they will be having a negative, which is going to indicating that this metals can liberate the H2 gas. It can liberate the H2 gas in the form of dilute acids. Okay, in the form of dilute acids. So, liberate energy when they are taking the electrons from someone, it's getting the means what is completely now dilute ಮಾಡ್ತಿದ್ದೇವೆ. We are diluting one solution, we are adding up one element to it, one solution to it, or one element only, liquid form of element, we are going to add it in something. Okay, so that time what happens? We are giving the electrons to that, right? It might go to the negative charge because we are taking the electron also, right? So our time nalli enaguttappa, that time it might liberate what? H2 gas also. It will liberate H2 gas also. Okay, this will be influenced by what? Enthalpy of atomization, ionization enthalpy, and hydration enthalpy. Clear? And hydration enthalpy. Done? Next, sorry, we didn't study this. Yes. Exceptions is what? Copper nalli E0 is going to be the positive. In copper, the E0 is going to be the positive itself, and here the copper is going to be, cannot be liberate the H2 gas from the dilute acid due to the high ionization enthalpy and low hydration enthalpy. Because of what? Low ionization enthalpy and low hydration enthalpy. Adar salvagi copper is going to be the positive one, means what? It's giving the electron. Giving. Okay, it's giving the electron. So for that purpose, it can't liberate the H2 gas. It can't liberate the H2 gas. Understanding? Clear? Yes. Next comes what? Magnesium. This is all exceptionals I am telling you people. Ee tara questions KCET nal bala keltare. This type of exceptional questions will be asked in the KCET. Done. It will be asked in the KCET. Be concentrated. Okay. Magnesium what? E0 is more negative than the accepted. So it is actually more negative than the accepted. Means what? It's giving the, taking the electron from someone always. Okay. Due to the low second ionization enthalpy and the, due to the what? Due to the low second ionization enthalpy, because of that it's always negative. Most probably it will be negative itself. Clear? Next comes the nickel. That is also E0 is actually exceptionally negative. It's exceptionally negative itself, and due to the high hydration enthalpy. Due to what? Due to high hydration enthalpy. Due to high hydration enthalpy. Clear? And zinc, that is E0. Zinc, that is E0 is more negative. Zinc, that is going to be the E0 is going to be the more negative due to the stable D10 configuration. Due to what? Stable D10 configuration. That is going to be what? E0 of zinc is going to be, it's nenapitkombidi because zinc mela bala questions kelidare. I will write it as important here. I'll write it as important. They have asked a lot of questions on the zinc. Okay. Idhar mela short questions sasi kelidare. Aita. Next comes what? Tens in the M3 plus and M2 plus. Okay. M2 plus means what? Oxidation states are changing there. Concentrate properly. The M3 plus and M2 plus electrode potential will reflect the tendency of the metal ion to the reduced form of +3 to +2 oxidation state. Okay. It's from +3 to +2 oxidation state. Now it is influenced by what? It is going to be influenced by electronic configuration, from the stability of the oxidation state and the crystal field stabilization of the CFSE and the hydration enthalpy. Clear? Concentrate properly everyone here. The influence means it is going to be influenced by a electronic configuration, then about the stability of the oxidation state also, then it's going to be dependent on the crystal field stabilization energy. So then separate act ನೀವು ಕಲ್ತಿರಬಹುದು ಬೇರೆ lessons ನಲ್ಲಿ, right? In inorganic chapter you have already learned this thing. India, I didn't understand your name amma, it's okay, but also I'll tell you hi. Okay. So now crystal field stabilization energy nu depend ಆಗುತ್ತೆ. So ಇವೆಲ್ಲ influence ಆಗುತ್ತೆ. ಈ 4 point influence ಆದಾಗನೇ ಇದು M3 plus ಮತ್ತೆ M2 plus will be having a standard electronic configuration. Clear? Now let's see how it is going to tend. Okay, means exceptional. Obviously D and F block elements means we need to learn the exceptionals, right? So Mn3 plus which is getting from Mn2 plus, which is going to have a high E0 value. It will be having a high E0 value also, and Mn2 plus has half filled DF configuration. Half filled DF configuration will be present, means what? It will be extra stable. Okay, it will be extra stable. It will be extra stable, and Fe3 plus it will be what? Fe3 plus is going to be what? Fe2 plus. Okay. 3 plus in the 2 plus means oxidation state is getting changed there according to the paired or unpaired electrons. Concentrate. We need to remember each and everything, then only we can remember it. Okay. So, amele Fe3 plus mate Fe2 plus nalli lower E0 value irutte. The E0 value will be completely low. Okay. Next, Fe3 plus, that is DF, is more stable than the Fe2 plus, that is D6. That is going to be what? Fe3 plus or D6. Okay. Yes, hi. Concentrate properly everyone, it's very important. So, Fe3 plus is going to be Fe2 plus, which is having a lower E0 value, and this Fe3 plus, that is DF, is more stable than the Fe2 plus, that is going to be the D6. That is going to be what? D6. So, now this CO3 plus, which is getting formed into the CO2 plus. Okay. Next one is cobalt, that is 3 plus to the 2 plus. Okay. Which is having a high E0 value. It is having a high E0 value, and the CO3 plus is less stable. CO3 plus is less stable, and CO2 plus has a higher CFSE, and it is a highest crystal filled stabilization energy. CO2 plus is having a highest compared to the CO plus 3, means compared to the cobalt is having less and CO2 plus is having more. CO2 plus is having more. Same, it is going to be with the Sc3 plus and Sc2 plus also. Same oxidation state irutte. This oxidation state plus 3 to plus 2 agide. ಇಲ್ಲಿ very low E0 value because both the things are going to be included there itself. Okay. Next, it is having a Sc3 plus has a noble glass configuration, highly stable. It's going to be the highly stable. Next comes catalytic properties, complex formation and the alloy formation. First comes the catalytic properties. Let's see quickly about the properties now. So, first comes what? Transition metals act as a catalyst due to, how it's going to act like a catalyst? It is because of the variable oxidation state. So, oxidation states will be variable, means what? Plus 3, plus 2, plus 4, plus 7 tankanu hogutte, right? So, oxidation state will be varying according to the, how it's going, moving down to the group, left to right, hege move akot hoguttalla, how oxidation states change akot hogutte, right? Then the formation of intermediate compounds. So, the compounds formation will be also different, right? Presence of the vacant d orbitals also will be present. Sometimes it will be empty whenever it's not getting reacted with someone. Sometimes it will be completely filled. Okay, so depends on that. High surface area for the absorption. So for observing the electrons, there will be a high surface. Means what? Wherever you go and stand, that time we will going to observe. Like that also it will be present, right? Examples in Togobodu, Fe, there is also a Haber's process, V2O5 with the contact process, Ni with the hydrogenation, and PT and PD with the catalytic converters. Then next comes the complex formation. Complex formational ಏನಾಗುತ್ತೆ? Okay. Now what will happen in the complex formation? Transition metals forms the complex compounds with ligands like NH3, H2O and Cn minus. Okay. It ligands like what? NH3, H2O and Cn minus. Now due to that small ionization energy because of the high nuclear charge and the vacant d orbital to accept the lone pairs. Clear? Concentrate properly. Yav tara agute complex formation that transition metals which are actually having a complex compounds there with the help of the ligands like what? NH3, H2O and the cyanide. Clear? So they will be having a small ionization, ionic size. Ionic size will be completely small. Then next, high nuclear charge will be present. Nuclear charge will be more little bit, and the vacant d orbital will accept the lone pairs. Vacant d orbitals will accept the lone pairs. Then next comes the examples. Few examples also they have given it. Just go through this. Next comes the alloy formation. From alloys formation also they will ask a lot of questions. Be prepared. Okay. Now we have a formations also. Okay. Let's go with the alloy formation. So, the transition metals from the alloys due to the similar atomic sizes. Due to what? Similar atomic sizes will be there. How the alloy formations will be happening? Due to its similar atomic sizes. If the atomic sizes are same, formation will be easy. Metallic bonding, and then next comes the miscibility in the molten state. So it will be having a miscibility in the molten state. That time also it will be very easy to form the alloys. Okay, easy to form the alloys. Now what are those properties? Okay, properties in the ಏನಪ್ಪ harder, that is will be having a corrosion resistance and high melting point. So these are the physical properties. Like example, harder, they will be very strong one, and it will be having a corrosion resistance also, and it is having a high melting point. High melting point idre ಜಾಸ್ತಿ ನಾವು ಯೂಸ್ ಮಾಡ್ಕೋಬಹುದು ಅದನ್ನ. Okay, if it is having a very low melting point, no, it's very difficult to use those compounds. Okay, this much you remember. This is a common thing. Okay, example, steel, that is Fe plus C. Brass, we can take it copper plus zinc. Bronze, Cu plus Sn. Dunem, that is Al, Cu plus Mn and Mg. So these are the few examples which we can take it for the alloy formation. Clear? Done? Next comes what? Formation of K2Cr2O7. Now we are going to learn some formations. ಏನಪ್ಪ formations you understand ಮಾಡ್ಕೊಳ್ಳೋಣ. So first is sodium chromate is more soluble than the potassium chromate. Okay, actually sodium chromate is actually more stronger than the potassium chromate. Why? Because the chemical reaction is going to be what? Na2CrO4 plus BaCl2 is going to form a BaCrO4, which is going to be in the gaseous form. We are going to get it in the form of gaseous, plus 2NaCl. Clear? What will be the chemical reaction? Na2CrO4 ಯಾವಾಗ react, sodium chromate ಯಾವಾಗ react ಆಗುತ್ತೆ ಎದರ ಜೊತೆ? barium chloride ಜೊತೆ. Okay, barium chloride ಜೊತೆ we will get barium chromate. Okay, we'll get a barium chromate plus 2NaCl. Done. Next, this orange colored solution which is there. Okay, this orange colored solution of potassium chromate with this barium chloride, which will give the yellow precipitate. Okay, which will give what for us? Yellow precipitate will be formed. ಯಾವಾಗ ಆಗುತ್ತದೆ yellow precipitate? When this orange colored solution is going to be of potassium chromate with a barium chloride, and of the barium chromate of a chromate is going to be the less soluble. Chromate is going to act like a very less soluble. Clear? What will be the chemical reaction here? So K2CrO4 plus BaCl2, which is forming BaCrO4, which is in the form of down, means BaCrO4 is going to be in the gaseous form, plus 2KCl plus 2KCl. This orange colored solution of the sodium chromate with barium chloride, which will give us the yellow precipitate of a barium chromate, and a chromate is more soluble, and a chromate is going to be the more soluble. Clear? So these are the alloy formation. Understanding? Next comes the chemical reaction at the end, how it's going to be. Sodium chromate oxide is going to get reacted with the BaCl2 to form that is barium chromate, that is going to be a BaCrO4 plus NaCl plus H2 will be the final reaction. Clear? How the formations are happening of Cr2O7? So K2Cr2O7, potassium chromate is going to be formed very easily with the help of the sodium chromate. Clear? Just we need to add up the chromate here. Okay, potassium last agi end ಹಾಕಬೇಕು. Okay, so ಯಾವಾಗ ನಾವು potassium ನ last ಆಗಿ add ಮಾಡ್ತೇವಲ್ಲ, at that time we are going to get the potassium chromate. Done? Next, now the potassium dichromate is prepared from the chromate ore, that is going to be the FeCr2O4. That's what I told you. Then afterwards fusion with alkali is going to happen, that is chromate ore is being fused with Na2CO3 or K2CO3. Okay, it's been fused with Na2CO3 or K2CO3. Then afterwards, in the presence of the air, it will form the Na2CrO4, that is about the yellow solution, and this is how the reactions are going to happen when we are going to fuse with the alkali. When you are going to do the fusion with the alkali, this is how the reaction are going to be forming. Then next comes the acidification. Here what happens is Na2CrO4 is being acidified with the H2SO4. Okay, it's been acidified with the H2SO4, which will form the Na2Cr2O7. Okay, which will form the Na2Cr2O7. Then the conversion of this K2Cr2O7 is what? Na2Cr2O7 is being treated up with the KCl. So this orange crystals of K2Cr2O7 will be crystallized out. It will be crystallized out. Done? Clear with the formation of the K2Cr2O7? Yes. Next comes the potassium permanganate. How the potassium permanganate has been produced. Now, prepared from the pyrolusite ore, that is going to be the MnO2, by the alkaline oxidative fusion. By what? Alkaline oxidative fusion. Okay. After that, what happens is MnO2 plus KOH plus oxidizing agent. Here the K2MnO4, which is actually a green mass. Okay, it's going to be the green mass. That oxidation of potassium manganate to the potassium permanganate. To what? Potassium permanganate. Now, this K2MnO4 plus Cl2, that KMnO4 plus KCl is going to be formed. Same way like that only we are going to get for the KOH also. We are going to get for the KOH. Same way for the decomposing on heating, we are going to get K2MnO4 plus MnO2 plus O2 has its product. Clear? This is the how the KMnO4 has been produced. K2Cr2O7 and the KMnO4 formation will be little bit same. Just the thing is you need to practice the reactions properly. Okay? You need to practice the equations properly, then only you are going to understand it. Okay? Okay. Now, these are the few important oxidizing reactions of KMnO4 which you can go through it. Okay, separately we have written it. So, this also you can go through it properly. This will be important for the KCET. Okay, KCET bala help agate reactions. Okay. Next, we are going to go for the inner transition elements. That's going to be the F block elements. Okay. Lanthanides, which are going to be the Se, PR. These are all the F block elements. That is inner transition elements. Lanthanides, actinides. So, I shown you people periodic table also. Periodic table nalli last two lanthanides with actinides kalitev namu anta helidde nanu. This is what F block elements is. F block element is all about the lanthanides and actinides. So, now lanthanides and actinides ಎಷ್ಟು ಇಂಪಾರ್ಟೆಂಟ್ ನಾವು ಡಿ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ ನಲ್ಲಿ ಕಲ್ತಿದ್ವಲ್ಲ ಅದೇ ತರ ಇಲ್ಲಿಂದನು 100% ಆಗಿ ಒಂದು KCET ಕ್ವೆಶ್ಚನ್ ಕೇಳ್ತಾರೆ ಎಫ್ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ ಇಂದ means what from the lanthanides and the actinides one KCET question is short. Okay, one KCET question is short. Okay. Next comes the lanthanides. That is electronic configuration of lanthanides is going to be what? Atoms of the lanthanides have the electronic configuration of 6x2 has its common properly. Now, we will D block elements ಬಗ್ಗೆ ಕಲ್ತ್ವಲ್ಲ ಅದೇ ತರ ಇಲ್ಲಿ 6x2 is a common one everywhere. Variable occupancy of the 4f level will be there and the most stable oxidation state is +3. There it was +2 and +3. Here it is +3. Okay. Now, tri-positive ions have a configuration of 4Fn. That is going to be N is going to act like 1 to 14. Means what? Here like this. Okay. Just remember this thing. This is also important. Okay. Now, lanthanide contraction, how it's going to happen. Now, this lanthanide contraction thing is going to be important for the PU board. Okay, PU board ಯಾರು ಕಲಿತಿದಲ್ಲ ಇದನ್ನಂತೂ skip ಮಾಡಬೇಡಿ ಆಯ್ತಾ. So, lanthanide contraction overall decreases in the atomic and the ionic radii from the La to Lu. So, atomic and the ionic radii will start decreasing from where? From La to Lu. Okay, done. Next, due to the poor shielding of 4f electrons, due to the pure shielding of 4f electrons will be there. Shielding by 4f electrons is actually lesser than the shielding by d electrons. Then the results, that is going to be resulting in the stronger nuclear attraction and a smaller size. Okay, that is going to be resulting in the form of what? Stronger nuclear attraction and it's going to be having a smaller in size. Done. Next comes what? Lanthanide, same way, +3 is the common oxidation state and +2 state will show the EuYbSm Tm, that is going to be the strong reducing agents also, and the +4 state shown by Ce, Pr, Nd, Tb, Dy, strong oxidizing agents. These are when it is having a +4 as its oxidation state. Okay, yavag +3 irutte, they will all common oxidation state. Okay, amele +2 bandaga state down, means it will be completely little bit down, that is going to be EU, YB, SM, TM. These are all going to act like a strongest one, which has a +2 as its oxidation state. Done. Next comes what? +4 as its state of oxidation state. That is going to be these. These are having a strongest oxidizing agents. Okay. Now, irregularity due to the extra stability of the empty half-filled or filled DF subshells. Now, these are the few elements of the F block elements which you should remember it, and we have given you people the electronic configuration also and the symbol. Okay. Cerium, it's going to be Ce. This will be the electronic configuration. According to that, you need to go through this box. It's very important. Okay. Practice the, it's not like it's very easy. Okay, it's very easy if you know how to write the electronic configuration, not necessary to worry about it. Okay, next comes what? We have a few questions related to it which has been asked in the board exams a lot of times, like explain the variation of ionization enthalpies in the D block elements. They have asked this question a lot. Next, the explain the variation of atomic and the ionic radii of the transition elements. This has been asked in the March 2019. So, you can just observe the atomic and the ionic radii will start decreasing. It will start decreasing with increase in the atomic number. With increase in the atomic number, it will also start decreasing. Now, this decrease in the atomic radii will become small after the midway. Okay, after the midway, it will become smaller. Done. So, this is how you write the answers for the questions. Done. Next comes the lanthanides. These are the some oxidation states of the lanthanides. How it's going to work? +2 ಯಾವ್ದಿದೆ, +3 ಯಾವ್ದಿದೆ, +4 ಯಾವ್ದಿದೆ, ಯಾವ ತರ changes ಆಗುತ್ತೆ oxidation state ನಲ್ಲಿ. This box is very important, guys. ಒಂದ್ಸಲ ಈ ಬಾಕ್ಸ್ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ರೆ ನಿಮ್ಗೆ ಎಲ್ಲ ತರದ್ದು F block elements ಫುಲ್ ಪರ್ಫೆಕ್ಟ್ ಆಗಿಬಿಡ್ತೀರಾ. ಓಕೆ, ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಬಗ್ಗೆ. Next comes the physical properties of those things. We have some physical properties. Then we'll study about the actinides also. Okay. Yes. So, the silvery white soft metals are there, tarnish rapidly in the air. Okay, and hardness will increase with increasing in the atomic number. So, the hardness of that will start increasing with increase in the atomic number. So, samarium is a steel heart and the melting points range between the 1000 to 1200 K. 1000 to 1200 K. This is going to be melting at 1623 Kelvin. Just observe the melting point, guys, the temperature. So, it's going to actually melt at 16,023 Kelvin. Okay, so much it is hot. It's like highest temperature, if we can say it. Okay, next, typical metallic structure and the good conductors of a heat and the electricity. It's a good conductor of a heat and electricity. Why? Obviously it will be a good conductor of a heat and electricity. Why? Because its temperature is how much? 16,023 Kelvin. Then next comes the many in trivalent lanthanides ions are being colored also. Why? Because they have unpaired electrons. For that purpose, they are also going to be colored. Then both the solid state and the aqueous solution, and the first ionization enthalpy is going to be according to the 500 to 600 kilojoules per mole, and the second ionization enthalpy is going to be at 1200 kilojoules per mole. Okay, first ionization yavagagutte, yavagadu 500 to 600 kilojoules tala iruttalla per mole ge, avag first ionization agutte. Adu aad takshana second ionization agodu next ಬರೋದು ಯಾವಾಗದು 1200 kilojoules ಇದ್ದಾಗ second ionization process ಆಗುತ್ತೆ. This is comparable with the alkaline earth metals like calcium. This is actually, this first ionization and second ionization is possible with the calcium. Okay. Then next, this promethium is actually a radioactive element in the 4F series. So, you should remember this also. They might ask in the multiple choice questions that promethium is actually a, okay, that is going to be the radioactive element, which is going to be the 4F series. Next comes the physical properties and its applications. Now, the best single use of this lanthanide is for production of alloy steels for the plates and the pipes. For the plates and the pipes, this is the best single use of the lanthanides. Okay, and a well-known alloy is actually a mischantal, that is which consists of a lanthanide metal, that is going to be the 95%, and the iron, that is going to be the 5%. Traces of S, C and Ca and Al. A good ideal deal for the mismetal is used in Mg, which is going to be based on the alloy to produce the bullets, shells, lighter flints. This all are going to be produced with this help. Okay, ಇವೆಲ್ಲ traces ಏನು ಯೂಸ್ ಮಾಡಿ bullets ಯೂಸ್ ಮಾಡ್ತಾರೆ. Like how we know already how shooting the bullet and all. Hi Chinny, hi everyone. You are telling to hi to everyone. Okay, hi Chinny. Very long time I have not seen you. Okay, lighter fleets will use ಮಾಡೋದ್ರಲ್ಲಿ bullets ನಲ್ಲಿ, shells ನಲ್ಲಿ, lighter fleets ನಲ್ಲಿ use ಮಾಡ್ತಾರೆ. Now, mixed oxides of lanthanides has been used as a catalyst in the petroleum cracking. Okay, some individual lanthanides oxides are being used in television screens and the fluorescent surfaces. Okay, in the television screens also is being used, and in the fluorescent surfaces also. Okay, in the fluorescent surfaces also it has been used in these things also. Even in the bullets, shells and all those things also it has been used. Clear? Next comes what? Chemical properties. Now in this chemical properties, this much you remember, then it will be easy for you. This is the basic chemical properties. Okay. Now this lanthanide is going to, with acids, if it is going to form, H2 is going to form. With halogen, LnX3. With H2O, LnOH3H2. And with the C, that is going to be LnC2. And by heated up with the N and Ln2S3. Clear? Now let us learn it in detail. Actinides. All actinides are believed to have an electronic configuration of 7s2 with variable occupancy of 5f and 6d subshells. Various occupancy of what? It will be various occupancy of 5f and 6d subshells. Clear? Sorry. Configuration of electronic configuration of 7s2 it will be there, right? And the variable occupancy will be how much? 5f and 6d subshells. Clear? Next comes 5f orbitals will begin to fill across the actinide series. So 5f orbitals will start it will start filling the orbitals according to its actinide series. Okay, according to its actinide series, it starts going to fill its electrons. Then these elements show the wide range of oxidation states due to the close energy levels of 5f, 6d and the and the orbitals. So this actinides are the radioactive elements. All the actinides are going to be the radioactive elements. Why? Because they have been present, they have been introduced also in that way, so that we have separated them in the periodic table also, so that we will understand which are those elements. Okay, yav the elements are understand aglike. Okay, and earlier members, example TH, PA and U, these were also present early. Now they have removed it a little bit. Okay, now relatively long half-lives later members of example like ES, FM, MD, these are all radioactive elements itself, and the life values range from a day to just 3 minutes. So means it will stay, that element will stay only for the 3 minutes. Life cycle is only that much. There's elements, life cycle is only that much. Done? Hi Bhageshri. Next comes the actinides contraction. How the actinide contractions are happening, let us check it out. So actinide contraction is overall decrease in the atomic and the ionic radii. So this contraction of the actinides is going to be, decreasing. It's going to be decreasing in atomic and ionic radii, in the atomic and the ionic radii, with increase in the atomic number of the actinides, with increase in the atomic number of the actinides. Okay, now poor shielding effect of 4f electrons. Done. The poor shielding will be there of 4f electrons. For that purpose only it will not go till the nucleus. Okay, it won't go reach till the nucleus. Next, increased nuclear charge pulls the electrons closer. So when it is going to be the increased nuclear charge is going to start increasing, then it's going to pull. Obviously, charges will start increasing, that will start pulling from the outermost shell, right? So that is what is happening. Then the similar to the lanthanide contraction, but more pronounced due to the 4f orbital characteristics. It means what? Actinides are real. It's a family only of lanthanide, okay? It's a F block element only. Lanthanide and actinides are F block elements only. Just the thing is, there is a little bit difference. Why? Because 5f orbitals means what? Actinides are more stabilized, okay? It means what? 5f orbital character will show the different one compared to the lanthanides. Okay, simple if you want to remember it. Okay, next, what is the actinide contraction in chemistry? Also, you can check it out. The ionic radii of the actinide elements in the picometer. In the picometer, how it's going to be. You can remember these things. Okay, this also is extra knowledge to you people. It will be really be helpful to you people who are preparing for the KCET and for the NEET and JEE. Okay. Next, actinide contraction में actinides show a greater range of oxidation state. It will show a greater range of oxidation state compared to the lanthanides. Most commonly, it will exist in the +3 oxidation state, and elements in the first half of the series frequently show the higher oxidation state. Means what? First half it will start with the higher one, like +3, +4 they will show. Then afterwards it will slowly it will start increasing. Okay. Firstly, they will show the higher oxidation state. You can just see NP and PU, which has almost 7 as its oxidation state, right? So, however, it is frequently how the series are going, that is starts decreasing. Then, it's starting decreasing. Clear, everyone? Understanding? Yes. Next comes the physical properties, that is silvery in appearance, display a variety of crystal structures will be there, and the highly reactive metals, especially when finely it is being divided. Okay. Now, all actinides are radioactive. Early actinides are going to be example these, relatively long lives like later actinides, and extremely short half-lives from the day to just a few minutes. Done? Next, applications of D and F block elements we have. Yes, this will be the last part. Yes. So, applications of D and F block elements. Here what happens is, iron and steels are the most important construction of the materials. Okay. Here in this, iron and the steels are going to be the important one, which are present in the DF, right? So, you will have important participate ಮಾಡುತ್ತೆ because of this, we all are surviving. Okay, now let's survive agodane athrinda, right? So this is very important to remember the applications, and produced by the reduction of the iron oxides, and the impurities is being removed, and alloying metals like Cr, Mn and Ni has been added, and the titanium oxide, that is TiO, is being used in the pigment industry. It has been used in the what? Pigment industry. And the magnesium dioxide, that is MnO2, it has been used in the dry battery cells. It has been used in the dry battery cells also. Okay, this magnesium oxide. Next, the battery industries which has been using the zinc, nickel, that is Ni, and cadmium, that is Cd, and the group 11 elements, that is Cu, Ag, Au, are known as a cognizant metals. Now, Ag and Au now mostly used in the collective items, and the UK copper coins are copper coated steel, and the iron catalysts are being used in the Haber process for the purpose of ammonium production. Next, the nickel catalyst enable the hydrogenation of the fats, and the silver bromide, that is AgBr, is being used for the photographic industry due to the light sensitive methods. Done. So this is what you should remember, the things about the applications of D and F block elements. D and F block elements. Clear, everyone? Understood till here? Yes. So let's see some questions also related to it. They will be asking for the board exams what type of questions are. Explain the variable oxidation states of a transition metals. Okay. Now how and what type of questions will be asked is, the variable oxidation state of transition metals are due to the loss of inner N-1d and outer Ns electrons, and the outer Ns electrons. So adar ಬಗ್ಗೆ full explanation ಕೊಡಬೇಕು. If it will be good, okay, ನಿಮಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತಿದೆ ಯಾವುದು ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಇದೆ ಅನ್ನೋದಾದ್ರೆ ಎಲಿಮೆಂಟ್ಸ್ ಅದು, ಈ ತರ ಬಾಕ್ಸ್ ಹಾಕಿ ಎಲಿಮೆಂಟ್ಸ್ ಅದು ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಬರೆದ್ರೆ you will receive a good marks. Okay, you might get a good marks. 4 marks are fixed only from this. Okay, you can get a good marks from this. Next comes 3D series transition metals exhibit +2. Okay, +2 has the most common oxidation state. Why? They have asked. It has been asked in the July 2014. So that +2 oxidation state arises from the loss of 2 4s electrons. So yavag +2 oxidation state form agutte, yavag there will be a loss of two 4s electrons. Okay, and this means that after scandium d orbitals become more stable than the s orbital. Hence, for that purpose, 3d transition metals will exhibit the +2 oxidation state as the most common oxidation state. Then next comes the name the element of 3d series which shows maximum or highest oxidation state, which will show maximum or the highest oxidation state. So these are the magnesium which is having an oxidation state of +4, which is having a highest oxidation state, which is the lowest one. You know it already. Sc will be the lowest one. Next, name the transition element which does not exhibit variable oxidation state. We know already that is Sc and Zn are the two elements which will not, means it will not show the variable oxidation state. We have learnt it in the theory itself. Then next, they have asked the calculate the magnetic moment of, we have studied the formula. There are two for problems which we can discuss it here. Calculate the magnesium moment of Sc3 plus, which is going to be the atomic number as 21. So N is going to act like a 21. So 21 minus 3 minus 18, that is going to be the 0 itself according to the formula. Clear? 21, N value is 21, 3, just substitute it, we are going to get as what? 0. Done. They have given one more example here. Calculate the titanium, that is 3 plus, that is going to be the 22. So 22 minus 3 minus 18, that will be 1 itself. Substitute the N value here. 1, 1 plus 2, that will be 3 here. So 1 plus 3, that is 3, 1s are 3, 3. That is going to be the root 3. Root 3 will be 1.73. Okay. You need to remove the root. If not possible, you can keep it in the root itself. No problem. You can keep it in the root itself. No problem. Sorry. Yes. So, you can keep it in the root itself, no problem. Done. Next comes the same magnetic moment which was actually asked in the 2015 itself, magnesium 25, same you can just find the atomic number, N value, how to find it you know already, atomic number of a magnesium minus the oxidation state minus the atomic number of the argon. Clear? So atomic number of magnesium is how much? They have already given, that is 25, 25 you have written, oxidation state also they have already given it, that is +2, we have written as 2 here, minus the atomic number of argon, that is going to be the 18, we know it, that is going to be 25 minus 2, it will be 23, 23 minus 18, it will be 5. Done? Ma'am, miss new correction ge hogtira. Nan correction hogtena. Yav correction appa? Yav correction hogli nanu? So these are a few questions. I have added up all the questions here which are present. I have added up few of the KCET questions also here which are present. Okay, try out these questions everyone. We'll try to solve 2 questions here. Try. Who will answer this? Let me see it now. Okay. The correct order of the number of unpaired electrons in the ions, that is Cu2 plus, Ni2 plus, Fe3 plus and Cr3 plus is the question actually. They have asked almost 4 options. Let me check how many of you are going to answer me this. Okay. Let's check how many of you are going to answer this question. Try out everyone. Let's see how many people will answer this. Try everyone, I'll give you 10 seconds. I'll have little water also. So which option will be correct here? Come on, tell it in the chat box. Let's see. Exam ga illappa. I won't go for the correction purpose. Okay, let's try everyone. How many people are going to answer it? Let me see. I'll give you 10 seconds again. So these are the few questions which I have given you people. Okay. ಸ್ವಲ್ಪ ಕ್ವಶನ್ಸ್ ಕೊಟ್ಟಿದ್ದೇನೆ KCET. Okay, try to solve those questions, everyone. Okay, so today I have finished with the D and F block elements full theory mugsidene. We have covered up with the PU board questions also, and we have covered up with few questions of KCET also in between. So I have given you extra KCET questions also in the notes. You can go through the notes and sit and solve it alone, everyone. It's not necessary like a burden yourself. First theory full perfect ಮಾಡ್ಕೊಳ್ಳಿ, ಅದಾದ ತಕ್ಷಣ ಇವ್ನ ಕ್ವಶನ್ಸ್ ಅನ್ನ ಟ್ರೈ ಮಾಡಿ ಸಾಲ್ವ್ ಮಾಡಲಿಕ್ಕೆ, ಆಯ್ತಾ? So this is what I wanted to tell you people. And one more important thing is, please concentrate more on the theory. Why? Because if you're perfect with the theory, you will be very much perfect while solving the questions of the KCET. And I'll give you one more example also. Few of the students are there, ಸ್ವಲ್ಪ ಸ್ಟೂಡೆಂಟ್ಸ್ ಇದ್ದಾರೆ, KCET ಪ್ರಿಪ್ರೇಷನ್ ಮಾಡ್ಬೇಕಂತ ಬರೀ ಥಿಯರಿ ಅಷ್ಟು ಕುಂತು ಓದ್ತಾರೆ, ಅದು ವರ್ಕೌಟ್ ಆಗಲ್ಲ. ಥಿಯರಿ ಆದಮೇಲೆ KCET ಕ್ವಶನ್ಸ್ ಅನ್ನು ಸಾಲ್ವ್ ಮಾಡಬೇಕು. ಕ್ವಶನ್ಸ್ ಎಷ್ಟು ಸಾಲ್ವ್ ಮಾಡ್ತಾರೆ ಅಷ್ಟು ನಿಮಗೆ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. ಡನ್. ಸೊ ವಿ ಹ್ಯಾವ್ ಅ ಲಾಟ್ಸ್ ಆಫ್ books also which you can refer it for the KCET, like example MTG. So this is a very good book which you can refer it for your question solving. They will give a very nice theory things also. Means one topic admele few questions they will give you which you can refer it for your studying purpose. Just a simple tip I wanted to give you people. Okay, till then, see you everyone. See you in the next class. Hope so everyone have understood it. If in case anyone is new to this video and now ಈಗ ನೋಡಿದ್ವಿನಪ್ಪ ಈ ಕ್ಲಾಸ್ ಅಂದ್ರೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ ಚಾನಲ್ಗೆ. ವಿ ಆರ್ ಗಿವಿಂಗ್ ಯು ಅ ಮೋಸ್ಟ್ ಸರ್ಪ್ರೈಸಸ್ ಆಲ್ಸೋ ಕಮಿಂಗ್ ಟು ಯು ಪೀಪಲ್. ಓಕೆ, ಸರ್ಪ್ರೈಸಸ್ ಈ ವೀಕ್ನಲ್ಲಿ ಬರ್ತಿದೆ ನಿಮಗೆ. ಮತ್ತೆ ನೀವು ಆಲ್ರೆಡಿ ಒಂದು ಶಾರ್ಟ್ ನೋಡಿರಬೇಕು. ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಬ್ರಿಂಗ್ ಅ ಮ್ಯಾಥ್ಸ್ ಟೀಚರ್ ಆಲ್ಸೋ ವಿಚ್ ಇಸ್ ಆನ್ ಫ್ರೈಡೇ ಶಾರ್ಪ್ at 8 o'clock. You are going to get a maths teacher. Who is that? That is a big reveal. So stay tuned till then everyone. Okay, till then, see you everyone. Bye bye.